pasa si el desierto está a la puerta de casa? Si el desierto está a la puerta de casa, la frontera es el bosque.
Dentro de los distintos tipos de bosque podemos encontrar los bosques complejos, que son aquellos que o bien tienen varias especies arbóreas o varias clases de edad y diferente tamaño. Con el calentamiento del planeta, pérdida de biodiversidad, cambios de uso de la tierra, los bosques complejos son una oportunidad y un seguro. Infinidad de estudios han demostrado que este tipo de estructuras son más resilientes y más resistentes a los efectos adversos de distintas perturbaciones. Pero no solamente desde ese punto de vista son importantes, desde el punto de vista económico, de servicios y bienes que nos proporcionan a la sociedad, este tipo de bosques lo hacen de una manera más eficiente y en algunos casos en mayor cantidad que otro tipo de estructuras más simplificadas.
Al tener o bien varias especies o bien varias edades o varios tamaños, pues permite que la provisión sea más diversificada. La ganadería, la producción de madera, con la obtención de setas o con la obtención de resina, llegado el caso.
Pero hay otro tipo de servicios que también son importantes. Están los servicios de regulación, puesto que intervienen en los ciclos de los nutrientes, del agua. El bosque, digamos que es un actor clave en todos este tipo de ciclos. Y luego están también los servicios culturales, socioculturales.
Hay un componente cultural muy importante en los bosques que muchas veces se nos olvida y que muchas veces estos bosques y la parte del paisaje está muy imbricado en la cultura de un territorio.
Son patrimonio de la población y son patrimonio de las sociedades.
Entonces tenemos que ser conscientes de cuál es la importancia que tiene la naturaleza para nosotros, que nos proporciona, ponerla en valor y en base a conocerla, pues poder utilizarla de la mejor forma posible.
El principal objetivo de COMFOR-SUDOE es generar una estructura de bosques complejos que puedan servir de modelos, de ejemplos para promover este tipo de bosques en la región SUDOE, que es un espacio del sudoeste europeo.
Son las regiones en las que estamos viendo que el cambio climático está produciendo cambios más visibles en estos bosques.
Primero hay una parte de interdisciplinariedad, entonces de ofrecer una mirada desde diferentes disciplinas y de diferentes campos de la ciencia sobre los bosques complejos y entender cómo la complejidad es un valor en sí mismo, ¿no?
Para fomentar, conservar y favorecer este tipo de bosques complejos, en el proyecto desarrollamos una serie de estrategias con los que pretendemos al mismo tiempo presentar una serie de herramientas que puedan ser después utilizadas por los gestores.
La primera es una estrategia de entender, de conocer qué es lo que es el bosque.
Tenemos una serie de estudios observacionales, es decir, parcelas de seguimiento y de investigación, en los que lo que hacemos es seguir la marcha de los bosques como fuente de conocimiento. Y ahí el proyecto está llenando un hueco que había en relación con la falta de ejemplos de investigación en bosques complejos.
Para ello hemos desarrollado tipologías de distintos bosques complejos, utilizando tecnologías tipo láser o incluso el servicio Copérnicus de la Unión Europea. Por otro lado, tenemos una estrategia de gestión y más concretamente de transformación de bosques monoespecíficos a bosques complejos. Y no solamente transformar aquello que ya existe, sino también para desarrollar nuevos bosques complejos. Finalmente hay una estrategia socioeconómica.
Uno de los aspectos fundamentales dentro del proyecto COMFOR-SUDOE pasa por la valoración del capital natural o la valoración de los beneficios que el bosque genera para la sociedad. Está basado en una metodología desarrollada por Naciones Unidas para tener un proceso normalizado y sistematizado de qué forma se puede incorporar la naturaleza en el modelo económico actual. actual. La herramienta que se va a desarrollar dentro del marco del proyecto COMFOR-SUDOE podrá ser utilizada por diferentes tipologías de gestores, gestores privados y gestores públicos.
En la parte social es estos aprendizajes de qué es el bosque para las distintas personas que viven en distintos territorios, porque hay diversos territorios dentro del proyecto, y luego a futuro lo que vamos a hacer es llevar todo esto a decisores políticos, a gestores.
Alcaldes, alcaldesas, grupos de desarrollo rural, personas que gestionan reservas de caza, cazadores, ganaderos, ganaderas, agricultores, agricultoras. La idea es construir una guía de cómo incorporar esa perspectiva de los actores sociales en la gestión forestal.
Uno de los avances que hemos encontrado en el proyecto, y la verdad que estamos muy satisfechos, es el grado de implicación de los distintos actores del territorio en las actividades del proyecto.
La investigación forestal requiere tiempo. Desde que la ciencia forestal está sistematizada a raíz del siglo XVIII, que empiezan a acumularse observaciones y empiezan a extraerse los primeros datos, nosotros hemos cubierto una fracción muy pequeña de la longevidad de gran parte de las especies.
Es un proyecto a largo plazo, esperamos seguir teniendo avances, pero creemos que los bosques complejos van a formar parte de la agenda política y de las tomas de decisiones en los próximos años.
For coming to this
based on the property
symposium on complex forest. We are going to present the results of the project COMFOR-SUDOE, which is an Interreg project. This event is also sponsored by UFRO. I will have a presentation about UFRO later today, for those who are not familiar with this institution, this organization. My name is Andrés Bravo Oviedo. I am the coordinator of the project and also the coordinator of the research group 1.09 of UFRO, which is about dynamics and silviculture of mixed forest. Welcome to the National Museum of Natural Sciences, where this event is taking place, and also I would like to thank all the people here and all the people who is watching this event, who is going to be broadcasting and recording in YouTube. So I'm going to start with the first presentation according to the agenda. If I'm able to do this. Full screen. So the first things that probably you ask yourself when you hear the word complex forest is, what is a complex forest? Well, actually, it's just a short name for complex forest structures. So basically, we are working with irregular, uneven age, mixed, two-storied, or some kind of combination of these structures. In general, these kind of forests have high structural and taxonomic diversity. And why this is important? Because currently, in a global change context, society demands more resilient forests, more ecosystem services, or at least more diversification of ecosystem services from the forest, but also society need to accept the kind of forest, the type of forest. So here is a summary of this idea. So you can see here in these three axes, The big box, the gray box, for example, could be a mixed forest. I think that most of us, or most of the society, thinks that a mixed forest is more resilient, can provide more ecosystem services, and is more acceptable from the point of view of society. On the contrary, monoculture or a plantation, like the one in the picture, it's the yellow box, is probably less resilient, it provides less number of ecosystem services, and is less socially acceptable. But as scientists, and also as just critical thinking, we must ask ourselves if this is true in all the cases. So, could be, for example, here, let's see if this works. Here, in this case, in the plantation, which is less resilient because, it's just one single layer with large continuity, so it's probably very, very dangerous from the fire perspective. And it provides very good, just one single ecosystem service, which is timber, for example, and could be or not, or couldn't be socially accepted. Do we really know that? If people can accept this kind of plantations, or they reject this kind of plantations all the time? The same occurs from the mixed stance in this example, the complex stance in this example. They are more resilient, they provide more ecosystem services, but do we really know if they are more accepted all the time, in all the cases, in all the places around the world, from the social point of view? So just ask yourself that. And this is the kind of things that in this project we try to answer. So anyway, what we believe is that these complex forests can really contribute to the United Nations Global Forest Goals. So the first, this reverse forest cover loss by sustainable forest management, reforestation, and afforestation. We believe that increasing complexity in the stands by planting new mixture or adding species would improve the resilience capacity of forest, contributing to the safeguard of ecosystem integrity. So this is the contribution, the potential contribution of complex forests to this global forest goal. The second global forest goal is to improve forest benefits and livelihoods. There are multitude of studies that show that there is a larger portfolio of ecosystem services, of mixed forests, of complex forests. So we believe also that complex forests can contribute to the achievement of this goal. The third global forest goal is to protect forests and use sustainable forest products. Here, planted forests have an important role to buffer pressure over natural ecosystem, natural forest. But if we plant mixtures instead of monocultures when we make plantations, this will also improve resilience from the very beginning. It's not only and increase the portfolio of ecosystem services. So it's another way to protect forests also. You know that these complex forest structures, this closer to nature silviculture, is more and more demanded by society, but also by funding agencies. So working on complex forests is a timely an opportunity for research to increase the capacity building, the scientific and technical cooperation. And Interreg is, it's part of this achievement also. The two final global forest goals, promote inclusive forest governance and cooperate across forest sector, can be also achieved from the perspective of complex forests, because the social awareness and concerns on forest ecosystem degradation threatens, like wildfire, droughts, and biodiversity loss, make public more prone to make decisions, to participate in the making decision process. And I think that if we promote these complex forest structures, we will also have a larger, bigger participation from the society, and also across sectors, as we will see in the rest of presentations during this morning. So the project COMFOR-SUDOE, which is just an abbreviation of complex forest in the southwest Europe. The objective is to promote complex forests, mixed, irregular, or some kind of combination of both forest types, and multi-species plantations. It's not only transforming or managing existing complex forests, but also creating complex forests from the beginning, from the scratch. We believe that this is a resilient adaptive strategy in response to climate change and declining biodiversity. And the project have promoted several actions in terms of restoration, social and economic. And I will show you some examples. The project is restricted in the southwest of Europe. As you can see here, a map of this region. But of course, the results can for sure be extrapolated to other regions. So within the restoration actions that we have implemented in the project, we have different experiments of diversification of monospecific pine woods. We have applied irregular shelterwood system and hardwood plantations within gaps. I will show you later in the morning how we did these experiments. And also we have established mixed species plantations. We have developed protocols and good practice manual on how to establish and manage mixed species plantations, and also you will have more information during this event, this symposium. We have also developed monitoring actions. We have developed a multi-taxa biodiversity monitoring. We have measured lichens diversity, fauna, soil communities, and in complex forests, and also in these experimental sites where we have tested different silvicultural systems to transform monospecific stands. We have also analyzed if there is any improvement of this multi-taxa biodiversity when we transform monospecific plantations into complex forest. We have also developed LiDAR cartography and a monitoring system of complex forests, which includes the identification of sensitive areas to forest fires in complex forests. And again, you will have more information during this symposium. From the economic and socioeconomic perspective, we have developed learning labs to raise public awareness and also participation of people. And we will develop social meaning of forests, so what the forest actually means to people, to rural people. We have also built a martelloscope network to implement different actions like these learning labs. I guess you are familiar with martelloscopes, but you will hear about this also today. And we have developed also a accountability system of natural capital in mixed forest. And we have created a sectoral group in this natural capital factory, web page. Another important action in the project has been education. We are in a museum. We have the opportunity to have many activities oriented to general public, to kids, to teachers, to high school teachers, for example. And we have also developed several actions to show the benefits and also, why not, some drawbacks of the complexity of forest. So this is my short presentation of the project. You will have more information in the coming slides, in the coming presentations on the project, and I hope you enjoyed the rest of the symposium. So thank you very much. So following the agenda, maybe I ask the technician if our colleague Mark Ducey is ready. We need to open the...
Right. Okay, thank you. Well, as I said, I'm here on the East Coast of the US, and I wish very much that I was with you there in Madrid. But I'm pleased to be here. Thank you for the invitation to talk, and I'd like to share a couple of very simple insights, perhaps, about how we might measure complex forests. The place where I am, I work at the University of New Hampshire. I actually live in the neighboring state of Maine. We have forests that look like this, at least in autumn. They're very beautiful. They're also very complex. This particular view, I can pick out about 8 or 9 species of forest. So they're very compositionally complex and also very structurally complex with deep vertical canopies, layering of species, lots of dead and downed wood. The management is complex as well, but I won't go too much into that. If we think about compositional complexity, if we map data from our National Forest Inventory for the US and we ask about mean species richness, or median species richness, you can see up in the northeastern corner of the country, a typical national inventory plot will have 5, 6, 7 species in a very small area. That contrasts with the western US, where a typical plot might have 1, 2, or 3 species. But we're not the most complex in terms of species richness. That's to be found farther south in the southern Appalachians. So it's a complex landscape that informs a lot of the things that I think about in terms of forest ecology, silviculture, and management. And so, yeah, it's just part of what we have to contend with. And yet, what we find is that many of our conceptual tools and our measurement ideas are really derived from much simpler forests, from plantation forests. Most of the ideas in forestry in the United States were imported from Europe 100 years ago. And of course, the ideas reflect the dominant paradigm of plantation silviculture. So I'm going to share some different ideas, but I want to be very honest what this talk is not about. It's not rocket science. This isn't some great idea that I had in the middle of the night that I woke up and said, "Ooh, this is going to change the world." Absolutely not. Nor is what I'm going to talk about something that I developed entirely on my own. In fact, you'll see I had some early ideas, and by early, I mean much earlier in my career, that other people have picked up and developed into something that might be useful. And at the same time, it's not necessarily something that I believe is magical or unique. The title of my talk was How Do We Measure Complexity, or How Should We Measure Complexity? This is one way. I do think it's potentially useful, partly because it's such a simple way of measuring complexity. And I think that has value when we're trying to wrap our heads around a very complex world. So what I will share is a simple method of measuring complexity, and its history is a little bit complicated itself. I was reflecting the other day, I've been in my current position for about 25 years, and some of these ideas go back that far, and they reflect a time when I was younger, and I hope I was less wise because I can look back now and see how unwise I was. Um, the origins, really the origins of this actually don't start with even with stand structural complexity. They start with ideas about measuring stand density. Some of you will be familiar with this measurement that goes back 90 years now, Reineke's Stand Density Index, or SDI. And the equation for that, I promise there will be relatively few equations here. The equation is on the top there. Stand density index really can be thought of as the number of trees per hectare multiplied by an adjustment factor for the quadratic mean diameter of a stand. So we have a reference diameter of 25 centimeters. We adjust the quadratic mean diameter. We raise that to an exponent. That gives us a sense of the competitive intensity of the trees when we multiply by number of trees per hectare. Now, later, nearly 40 years after Reineke developed his original index, which he intended as a simple tool, other people began thinking about how you might apply that in more complex forests. And the idea was to use an additive version where we would add up essentially the SDI of the components of a stand, usually envisioned as diameters of trees or diameter classes of trees. We would add that up to get an additive version of the density index. And that has some attractive properties, which I was thinking about as a young scientist, particularly as we think about measuring complex forests. And then I got involved in a minor little controversy, as scientists are wont to do. We argue over very small things. And somebody very smart made a statement in a paper that I didn't agree with. Yes. Okay. Let me try muting to see if it's coming from me. I told you it was 4 in the morning here. You can't trust anything I do. So you want me to log out? Okay, am I still on? Okay, but now I've lost my presentation. Let me get back to that. Okay. Hold on. Okay. Uh, okay. So you can hear me now, and you can see my slides. Okay, great. All right. So again, just to briefly go back to this slide, this isn't rocket science, and like much in science, it depends on the development of ideas by multiple people over time. I had some early ideas that I think other people have made useful. Again, going back to stand density index, I think the system was very wise to make me inaudible when I started talking about equations. Originally, this idea came from thinking about stand density index. On the top, we have the original version of Reineke's stand density index, which is a stand level index, and it adjusts number of trees per hectare for the size of the stand as measured by the quadratic mean diameter. The bottom equation shows this additive version where we add up the stand density index of the components of a stand, usually envisioned as diameter classes. And about 50 years ago, people started talking about using this to measure the density of more complex forests. And it has some other advantages as well. So that brings us to the controversy that sort of started this, and controversies in science are often over very small things. A very smart person, John Shaw, made a statement in a paper that when I was a young scientist, I didn't really agree with, that these two versions of the density index really were at heart the same. And I think he was trying to say something that I did not understand at the time, because he's smarter than I am. And I do need to tell him someday that I think he was actually right if I had understood what he was saying. But I was hung up on the mathematics of it. And I started working out some properties of these two ways of measuring stand density to sort of show that they were different and to understand when they would be most different, so that we could test them. And in a couple of papers, which are long lost, but if anybody wants them, I'll be happy to send them to you, I sort of worked out some of these details. For example, the additive version is strictly less than or equal to the original version. And they're only equal when the diameter distribution is very, very simple, essentially a spike centered on a single diameter. Since that's true, the ratio is always less than 1. And being mathematically inclined, I worked out some properties of that, especially when the stand diameter distribution follows a Weibull distribution, which is one of the most common parametric forms, one of the most common density functions that we use to characterize diameter distributions in forests. So, for example, here's an example of 4 different Weibull distributions. In the red, you can see a fairly simple distribution. All of these have the same quadratic mean diameter, incidentally. And when this shape parameter, C, is 8, we have a fairly simple bell-shaped distribution. It almost looks normal. And the ratio of those two ways of measuring stand density index is nearly 1. On the other hand, as we change that shape distribution, when it goes all the way down to C equals 1, we actually have the exponential distribution, which is the same as de Liacourt back in 1897 advocated as sort of a model distribution for an uneven-aged forest. And there we see that the ratio of these two has fallen to 0.82. So for me, this was a curious result. I showed that it can go even lower in the case of bimodal forests, where we have two distinct cohorts or age classes with very different diameters. But for many forests, this ratio is going to be, 0.7, 0.8, up to 1, never more than 1. And for me, this was a curious fact, and I didn't think much of it. But some other people picked up on that. In particular, John Shaw, with whom I was arguing at the time, read the papers, and he and Jim Long, the famous silviculturist from Utah, started using that ratio as an index of structure or uneven agedness as they were trying to screen plots to fit maximum density relationships. Remembering that Reineke's original relationship is for simple single cohort stands, they wanted to get rid of the complex stands in fitting their relationships. And they started using it that way. I read those papers. I said, that's not what I meant. And that's not very interesting to me. So I largely ignored what they were doing. And that was a really dumb thing of me to do. And people kept doing it. More recently, I had reason to turn back to some of those old papers, and I did a quick literature search, and I found that even more people were using it, although the very recent trend is to subtract that ratio off from 1. And what that has the result of doing is that when things are not complex, the value of this structural complexity index that people are calculating is 0, and it increases as a stand becomes more complex. So that seems sensible from an interpretive standpoint. So going back to some of those properties that I had worked out and then working out some more, without going into horrible equations, what can we say about this structural complexity index? Well, since the ratio is strictly less than or equal to 1, that means that this structural complexity index is going to be bounded. It's going to be a nice number between 0 and 1, but it's usually going to be pretty small. It'll be 0.1, 0.2, 0.05. I did go through and work out some of the properties for a wide range of distributions that fall in a common family. And it turns out that if you are willing to say what the distribution is, we can calculate the structural complexity index from an equation, although the equation is going to be the kind of equation only a biometrician could love. It'll have these gamma and beta functions in it that luckily MATLAB or R can calculate for us. More interestingly, it's scale independent. Stretching or shrinking the diameter axis doesn't affect its value, and I'll put up an example of that in a minute. And also potentially interesting, it's an example from what could be a family of possible indices of structural complexity. And in fact, it's related to, but not identical with, the coefficient of variation of the diameter distribution. So we can understand what this index is mathematically, and we can make simple graphs to illustrate it. So here's the graph that we had before, changing within the Weibull distribution. It's just 1 minus the result that I put up before. So for the distribution in red, which is relatively simple, this structural complexity index is very, very close to 0. But as we change and flatten the distribution and move to the exponential with c equals 1, this structural complexity index increases. It's nearly 0.2. So that gives you a sense of the range of behavior that we might expect. When I talk about it being scale independent, what that means is that if we simply multiply the x-axis by some number, and then we have to rescale the diameter distribution so that it integrates. Here's 4 different distributions, but they all have the same so-called shape, right? They have different quadratic mean diameter, which in this case actually happens to equal the value of the scale parameter of the Weibull. That's not always true. In this case, it is. In this case, the quadratic mean diameter is varying considerably, but the basic shape of the distribution is the same. And so the structural complexity index is also the same. Now, is that what we meant by structural complexity? Well, if by structural complexity we meant lots of big trees, clearly that will be what we will have with the red distribution. It will not be what we have with the black distribution. And in this case, our structural complexity index is insensitive to that. But that's part of the meaning of the index. So maybe this index measures complexity in the way we want, or maybe it does not. That's something to think about. And as we're thinking about it, we should be asking ourselves, is it a good idea? Well, I like it from a certain perspective because it does tie back to how growing space or competition happens between trees. It's related to some approximate ways of measuring relative density within a forest. If we thought that this additive stand density index really was the way to do it, there's an underlying relationship, and that's attractive, although I'm still struggling to spell that out in the clearest way possible. And it's only approximate if we move to mixed species forests and the species have very different maximum density. So yeah, it's a simplification. It does have some practical advantages. For example, one of the other ways we like to measure structural complexity is to calculate, say the Shannon's diversity index of a diameter distribution. But that requires us to put the trees in diameter classes, and how we do that will affect the diversity index, and that's not very attractive. Also, additive stand density index and SDI are both easy to calculate from ordinary data, so it's very easy to calculate this. On the other hand, it's always easier to calculate a new index than to test a new index. So I'll give you a couple quick ideas of how we're testing that, and then we'll wrap up. So in our own work, now that I'm aware that this idea is out there, we're looking at long-term trends in mixed hardwoods at the Bartlett Experimental Forest, where we have an 85-year sequence of permanent plot data over a very large sample size, 440 plots. So just looking at the behavior of structural complexity and how it changes through time and how it changes in space. One of my graduate students, Heidi Giguère, has discovered some historic data from old-growth kauri stands in New Zealand. Those forests are being very heavily affected by forest health concerns, so they're essentially being lost. Heidi's very interested in those forests and is looking at how SCI can inform our understanding of the dynamics. Another colleague, Dr. Mike Simmons, is using SCI to look at insect community assemblages across tree compositional gradients and now structural complexity gradients in our area. And to me, this is the kind of testing that we want to do. If structural complexity matters, we should be able to say what it matters for. And finally, another of my graduate students is doing an intensive look at how SCI relates to other field and LiDAR-based metrics of forest structure. So potentially we can map it and understand where it's redundant or similar to things that we already calculate. Finally, I've been looking at patterns over large areas, and here's a map of the median structural complexity index, again, for the lower 48 states in the US. And not surprisingly, you see that it's very complex in some of the regions that are also species diverse, but the median structural complexity index is also somewhat elevated in parts of the Western US where the stands are not so diverse. And this takes me back to my original interests in that ratio. This really highlights that we have structurally diverse stands across a wide range of locations. It's become very popular to try to do large national scale assessments of stand density. And many of these depend on the original form of Reinecke's stand density index. But what this map shows is that over many regions, the divergence between the additive form and the original form is substantial, more than 10%. And that should give us pause. It means that we should also be thinking about the best ways of measuring stand density along with stand structure. So with that, I'll wrap up. There's this nice, very simple structural complexity index that's out there in the literature. It's easy to calculate, and at some level, it's conceptually related to the partitioning of growing space within a complex stand. It has pretty well-defined mathematical properties. That's nice for somebody like me. We know how it works in terms of computation and relationship to diameter distribution. And some preliminary testing suggests that it actually is a good covariate. It's a good predictor of other ecologically relevant variables. But again, the national level patterns of this index within the US suggest that we need to be more careful in thinking about structurally complex stands when we do these strategic level assessments. So that's what I have to share today. I'm really looking forward to hearing the other talks. So I will wrap up, and I don't know if we have time for questions.
For questions? Okay, for questions. And also those who are watching the presentation in YouTube, you also have the opportunity to make questions. You can write in the message section if you have any question. So please, I open the floor to the public here. Anybody of the attendees, do you have any question? Yes, we have one question. Mark is Miren del Rio, who is going to ask you.
Hi, Mark. But thanks for your presentation. It was very interesting. My question is, because you mentioned that, maybe I didn't understand well, that it is related somehow to the coefficient of variation of diameter. And if you test this relationship between this structural complexity index, how is this relationship, or how is between the coefficient of variation and the index?
Sure, that's a great question. So there's on hand, if we put the equation for the coefficient of variation of the diameter distribution next to this structural complexity index, they don't look a lot alike. But if we rework them a little bit, we can get them into a common form. And so that's one aspect of the relationship. They can be viewed as special cases of another bigger equation. It's also true that, roughly speaking, this structural complexity index will increase as the coefficient of variation increases. They're correlated, but they're not identical. If I calculate them for a large number of stands, depending on the variation in structure that's there, the correlation is going to be 0.8, 0.85, something like that. And that's different enough that they will potentially pick up different things. But they're both, in a sense, scale-free also, in that if you think about the coefficient of variation, one of the reasons we use it in statistics is it expresses the variability as a fraction of the mean. So as the mean increases, it's often stable. In that sense, this SCI is also stable. So there's similarities, there's some shared mathematical underpinnings, but they're not identical, and I wouldn't expect them to be identical in practice. So that's the level of sharedness, I guess. I do have a paper that I keep saying I'm hoping to submit next week. I'm hoping to submit next week, and I know many of you can sympathize. We all have those papers that works this out and has some graphs of that. And as soon as I get that finished, I'd be happy to share that if you would remind me that I said so.
Do you have any other question here, or maybe remotely, YouTube? Is there any question? No? Okay. Just one comment. Thank you very much for your presentation, Mark. Now I can see you. I think this, this index probably is called to be an important asset in forestry for sure, if it is tested. But I wonder if it could be related to other approaches that take into account, for example, the species proportion by area, in terms of the stand density index. Because you mentioned in your presentation that the ESDI is always less or equal to the SDI. So yes, I think that probably this is because this species proportion by area concept is not taken into account. I don't know, maybe.
I agree. I think that further development that would include species would be very helpful. Right now, it's just a structural complexity. But if there were a way to incorporate both species and structure in a measure of complexity, I think that would be really, really very interesting.
Very much. Thank you very much, Mark. You can go to bed, maybe.
No, I stay awake and listen to talks now. I've had coffee, and there's so much good coming up. I'm eager to hear.
So we can go on with the presentations, with the agenda.
Thanks. This folder. Okay. This one here.
Yeah.
Perfect.
All yours.
Yeah. Okay. So, good morning, everyone. I will present the methods that we used to establish forest type for the Iberian Peninsula. And we will focus on the coverage of species according to the canopy layers. This information is important to understand the structure, the state, and the composition on forest stands, and also related with understory fuel characteristics can allow to predict the wildfire's ignition and propagation. Here you have in this scheme a representation of species cover in 7 layers for vertical structure, so high classes. This information can be gathered on national forest inventories, which is a tool important to assess the status and trends and represent the most complete spatial distribution on stands and forest structure. However, this information regarding the vertical structure often does not exist in all the national forest inventories, or is generally collected in a non-harmonized way between countries in Europe, which of course compromise the comparability. So, in the sense and on the scope of the Diablo H2020 project, which aimed to harmonize national forest inventory data on Europe, we start a set of different meetings and discussions, Isa from Portugal and the team from INEA in Spain, with the objective to have an homogeneous characterization of Iberian Peninsula forests, also to define to have definition of the vegetation and vertical structure of the main forests in both countries, to classify and identify what are the forest types that we have here common for the both countries. So we used the third Spanish National Forest Inventory and the fifth Portuguese National Forest Inventory to start this work of harmonization, to assess the composition of the species in both inventories, dominance, and the percentage of cover of each species in the vertical space defined by the 7 canopy layers. Although the National Forest Inventory for Spain don't have the same threshold as we used in Portuguese NFIs, so this threshold were adapted to the Spanish NFI data. For the Spanish case, we estimate the crown length and the crown diameter based on height and stem diameter for a long set of data from 250,000 trees. And these crown estimations, together with the density, were used to estimate the percentage of cover by structure. After this harmonization regarding the vertical structure, we looked at the species composition in both inventories. And we start here to show a common legend for the groups of trees or tree groups for both inventories, and we establish 18 classes based on dominant species. And then regarding to the shrubs and herbaceous species, we grouped in 13 formations, taking into account the hierarchical categorization and giving in the Spanish forest map. And also we looked to their physical and ecological characteristics to have a more homogeneous shrub formations. So here you can see the 13 shrub formations for both countries. I will just highlight here one of them. In this case is a formation with the code 230, which is related with the species from the Fabaceae family. So you can see that in Portuguese, which is this one, in the Portuguese NFI, we describe less the species, we identify more for the genera, and then in Spanish NFI, they describe more the species. For example, the Citizus species. In Portugal, we only identify the Citizus. And in Spain, you have Citizus grandiflora, Citizus coparius, Citizus striatus, villosus, and etc. So after the harmonization of these two important components, we select the plots where we will apply this harmonized information. We select a set of 55,000 plots. After deleting some wrong data, and also we are not using plots from the islands, from both countries. And for each plot, we are using a set of 217 variables, which are related with the species and shrub formations, which are 31 in total, and each information from each species in the 7 layers for vertical structure, including the litter. And after the selection of this data set and using a k-means clustering algorithm, a set of clusters were identified, and the interpretation and description of these clusters lead to establishment of the 28 forest types that characterize the forest in Iberian Peninsula at the level of the tree component and shrub formation. And here is the list of these 28 forest types. We add a code of one of each forest type according to these 3 criteria. One is related with the canopy cover, if it's a closed forest, an open forest, or have an average density. Then we also code regarding with the composition, if this type have more incidence of shrub or tree dominance, or have a mixed dominance. And then we add the code of the dominant species or shrub species, or a mix if it's not defined a dominant one. After that, a cartography representation of these 28 forest types were done. We used land use and land cover maps of Portugal and Spain to do this information, and each plot of the National Forest Inventory that are associated with a forest type then were associated to a polygon of the land use and land cover map. So each polygon of this land use and land cover map have only one forest type associated. Just to show here 2 examples of these forest types, where we can see in each vertical layer the percentage of cover corresponding to each species or groups of species, and also the distribution in the Iberian Peninsula. So what we can see from this one is a forest type dominated by a tree. In this case, is a closed forest dominated by Fagus sylvatica. In the lower class heights have shrub formations with the code 110, with species with Cuscus aculeatus, Daphne, and other ones. Then we also have formations from species from the formation 210, and others is related to all species that do not reach 3% of coverage in at least one of the 7 vertical high strata. In the opposite, here you can see that we have more percentage of cover in the higher high classes, and here, because it's dominated by a shrub formation, of course, we have more percentage of cover in the lower high classes. In this case, is a formation with dominated by cistus with Quercus ilex. Just to show you, of course, we cannot interpret this scheme, but to show the diversity of graphs of one of each forest type, we can see at least that the ones dominated by tree have more percentage of covers in the higher classes, and the ones dominated by shrubs is the opposite one. And here is the description and the cartography of one of each forest type for the Iberian Peninsula, which we consider that represent a multi-use tool describing the forest land with a lot of applications on large-scale landscape analysis, forest management, and conservation. Briefly, just to show all of this information represented for the Iberian Peninsula, where we can see that the shrub formation are generally widely distributed in the forest area of both countries. However, their abundance in terms of cover is lower comparison with tree species. So around 70% of forest types are dominated by trees, in this case, trees of the genera Pinus and Quercus. And I will show you briefly 3 examples, which is, this is curious because these 3 forest types are dominated by different types of species, but in the lower high classes are dominated for the same 3 shrub formations. In this case, is a closed forest dominated by Castanea sativa. And here we have an example of a conifer forest and eucalyptus groups, which is a Pinus spinaster forest. Again, in the 3 formations on the lower classes are the same. And the other example is a forest type dominated by a shrub formation. In this case, is a dense xerophyllous shrubs with various tree species. So, and the one more dominated is the formation with 110 with species like Ruscus aculeatus, Lonicera, and Rubus. We also did the correspondence of our forest types with the European classification of the European forest types, and we did the correspondence at category level and type level. Of course, this is only applied for the forest types dominated by trees. And we think that this information can be used for comparison at larger scales, allowing cross-border analysis. The developed method is also adaptable to an update dataset from more recent NFIs and to other study areas. And that's what we did next in the scope of the COMFOR-SUDOE project. We use the area of the partner University of Oviedo, located in Galicia, where in this case we already used the fourth Spanish National Forest Inventory, where we established the forest types that are present on this study area. And we did also for Portugal, for the study area in the north, in this specific area of conservation of Alvão-Marão, where we established the forest types with the previous National Forest Inventory, the fifth, and also to the more recent one, to the sixth National Forest Inventory. Finally, just to show you that after that we also did a global complexity index for one of these forest types, using values of each species or groups of species per high classes based on the hill number. And the results show that the forest type OM mix, that is an open forest with a mixed dominance, it's the forest type with a high complexity, since it includes a variety of species mixtures and structure, and also other forest types with a higher global complexity are two dominated by shrubs and one also dominated by trees, in this case different types of pines. Then we looked to the complexity just for the composition, and we also used the Hill index for this analysis, and the results showed that the forest type with the highest complexity of composition are the same forest types as the global composition. So this global composition are more related with this complexity of composition. Here are these four forest types with more complexity in terms of global and composition, in where all high classes are represented and with species diversity. And then we looked to just the complexity of structure, also using the Hill index, where we see that also two of these forest types, the same that are with highest global complexity and composition complexity, are have also the highest values here. And just to show you the representation, the scheme representation of these four forest types. And it's all for now. Thank you.
Thank you very much, Leonia. So now I open the floor to any question here. No questions? Maybe in YouTube? No? No questions in YouTube? Yes, there's one question here.
Mm-hmm.
Yes, thank you for the presentation. You ended up with 28 classes. Why not 21 or 32? Why did you choose to stop the K-means algorithm at 28? Is it? Did you try to make a sensitivity analysis?
We try to not have big, not small forest types classes, or not big. We try to have. In fact, in the beginning, it was, I guess, 22 or 23, but one of them it was so big that we decided to split and to make it smaller. I guess it's not, we don't have a number in the mind. The results show that, and we use it that, yeah. It's more related with, let's say, the homogeneous composition and structure of one of each than related with the number in itself. Yeah. I don't know if you want to add something.
Thank you.
No. Okay.
No. So, and now you have all these forest types. What's next?
Well, at least we think we can use this information for other countries, because the methodology is already established, so it will be nice if other countries could apply this methodology and use this type, because in terms of the comparison, it will be nice, at least for the Mediterranean countries, could use this approach and have this tool to characterize their forests, yes. And also, as we show in terms of the evaluation of the complexity, as we are in the complex project, of the complexity could be very useful, yes, to estimate what are the complexity of the forest that we are dealing with, yeah.
Thank you.
So maybe Professor can say, yeah.
Francisco Rego from the group. Now, just to indicate that the 7 height classes have been used for a long time for bird studies, diversity of bird species. So it's very common presentation that is related with some biodiversity components. And I think that's why we selected these height classes, and it were included in the National Forest Inventory studies. I would highlight also that for our surprise in the analysis of the data, the shrub component and the lower height classes were very, very common and very important from the functioning of these systems. And so instead of looking only at the trees, and we saw this great presentation this morning on the diameter classes of the trees, in the Mediterranean ecosystems, it's much more than trees. We have trees, but we also have shrubs, we have litter, we have herbaceous species, and I think we think that this would allow also for a better connection with biodiversity components and for fire propagation and other ecosystem properties. Just to highlight these aspects. Thank you.
Thank you.
Thank you very much, Leonia.
So now, following the agenda, next presentation is by Tan Fon. Yeah. Did I say it well? Okay. From the Instituto Superior of Agronomía also. Characterization of mixed forests in Portugal. So you have, which one is? Which one?
I think it's this one. Yeah. Thank you.
Okay. So the floor is yours.
So good morning. My name is Phương. Maybe the name is quite not common in here, so let me introduce my name again. So Today we'll present a very brief interview about mixed forest in Portugal. And I divided my talk into 4 main parts. Like, first one is just the overview of forestry in Portugal, and then how we make a map to show the distribution of mixed forest in Portugal based on the photo interpretation point, which is created by the result of the aerial photography, and also based on the basal areas. The data set used is from the field plot. And I will show some common photo about mixed forest in Portugal. And finally will be the distribution of some irregular pure stand in Portugal. And first is some definition of forest land and type of plot, type of stand in Portugal, because the definition might be different between Portugal and other countries. So in Portugal, we define forest lands as the area covered by forestry, with the areas is more than 0.5 hectare, and at least have 20 meter wide, with the tree higher than 5 meter, and the canopy cover for at least 10%. So from that definition of forest land, the pure stand is the forest land composed of one or more than one species, but one of them will occupy more than 75% of forest cover. So the mixed stand will be the forest stand composed of more than one species, and none of them occupy more than 75% of the forest cover. And the unevenage stand is the forest stand composed of trees distributed by different age class. So this is the brief. The first map on the left-hand side, I think, is the distribution of species across Portugal. So this is the list of species, but because due to the limit time, I will talk briefly about eucalypt, because eucalypt right now is the most common species in Portugal based on the inventory, National Forest Inventory in 2015. And the table on the slide is the distribution of forest, of area of the forest by the different type of ownership from 1928 to 2020. And it's in many countries, most of the forest was owned by the public. But in Portugal, the pattern is a little bit opposite. Like most, except in 1974 and 1982, the rest, the private sector own more than 90% of the forest area. So if you look at the nearest year, 2020, like the communals and private sector almost own more than 99% of the forest areas. So yeah, so that leads to a very difficult for Portugal to manage the forest, as most of them belong to the private sector. So based on the point location, we create the map of mixed forest. The data we use is the National Forest Inventory data and the field data, with the 2 criteria, like the land use is the forest land, and the primary occupation and secondary occupation are different species. So from 2 different data sets, there's so many different types of mixture, but we list here top 10 mixture that occupy most. And you can see like there's a similar patterns, like 8 to 10 species, mixed species, appears in both National Forest Inventory and the field data. There are 2 different mixtures that are different. For example, like in National Forest Inventory, we saw the mixture of eucalypt and broadleaf, or the cork oak and broadleaf. But in the field data, the mixture is eucalypt and cork, or eucalypt and other oak. I think that could be explained by because the data from National Forest Inventory is collected by the aerial photography, and sometimes it's difficult for the aerial photography to determine whether the broadleaf is the cork or the oak. So it's not very clear, clearly to identify. So when they do the field data, the way they determine the species could be more easier. So I think that could lead to the difference of the orange, the two last orange and two last blue columns. And so in here is the distribution of mixed forest beyond the point location, because we choose to present only top 5 species from the National Forest Inventory, because if we put all of them in here, it's kind of difficult to comparison and analysis. So you can see the kind of similar patterns between 2 of them, but the one from National Forest Inventory, they have a high density of the point than the field data. Like for example, the cork, or the blue one, or the green one, or the red one, they're quite located in the same area. So the red one is for cork, oak, and maritime bice, and the green one is for cork and stone pine. So in the next part is the distribution of mixed forest based on the basal areas. And to create that map, we use the field data with the following criteria, including the land use is the forest land, and the plot have at least 2 species, in which no species have basal area accounted for more than 80%, and the minimum values of diameter at breast height of each tree is 5 centimeters. So the threshold under the scope of the COMFOR-SUDOE projects is different from the one we use in the Portuguese National Forest Inventory, which I mentioned below is 75%, and for the canopy covers, and 7.5 centimeters for all species, and 5 centimeters for the eucalypt. So based on the basal area, we also have the category of mixed forest. So the eucalypt and maritime bice again account for the most percentage among other species, and these are the top 5 species that accounted most in the mixed forest in Portugal, and 5 of they could be broadleaf with the coniferous mixture, broadleaf with broadleaf mixture, and other mixture. So this is the distribution of mixed forest based on the basal area, but I only, again, show only the top 5 species. And you can see the maritime bice and eucalypt. That with the color is black. The location of them is quite similar in comparison with the 2 previous maps. Yeah. And there are some photos about the mixed forest in Portugal. So the first one is eucalypt and maritime bice, accounted for 15%. So this one is for cork and stone pine. And this is for cork and maritime bice with 7%. Right now I don't have the photo represent for other cork and maritime bice or cork oak and home oak, but I will add later. And this is the other mixture. We take the example about cork, oak, and eucalypt. And finally, because complex forest, including mixed forest and pure forest with irregular structure. So here below are the distribution of pure stand, but with the irregular structure in Portugal. So among species, cork, oak, are the ones that have the highest percentage of irregular structure in comparison with all of the pure stand, and come after by maritime bay. Even though eucalypt was the most common species, but maybe because it's a plantation, so they don't have much in irregular structure in comparison with other species. And finally, before ending of my presentation, we do some analysis and comparison about eucalypt pure stand and the mixture between eucalypt and cork oak to see whether the species might show better basal area when they grow by them, when they will grow alone or when they grow together with other species. And the horizontal axis, the x-axis, showing the different dominant height group of eucalypt. So we expected that might be when we growing eucalypt with cork, eucalypt will have a higher basal area per hectare per plot. But in fact, when we do the comparison, eucalypt might prefer to grow alone rather than with another cork. So, but we just test simply one example, one cases about eucalypt pure stand and eucalypt cork oak. Maybe there will be another mixture combination show the higher basal area of species than this case, and we are still continuing to analyzing and comparing other mixture species and other species. And maybe when we have other interesting results, we might share with you later in the future. So that is the end of my presentation. Thank you so much for your listening.
Thank you very much. So now, time for questions. Do you have any? No, in the internet? Okay, we can go on. Thank you very much for your presentation. And now is the time for Agresta, for Jorge Olivar, and which one is? Okay. So it's a methodology of quite similar this part of the session, classification of complex forests, in this case using LiDAR. So the floor is yours.
Thank you. Sorry. So, thank you. Good morning. My name is Jorge Olivar from Agresta. And I wanted to show you one of the products that we have developed for this COMFOR-SUDOE project, which is the methodology for classification of complex forests using LiDAR. First of all, the study area that we use for this methodology is the Sierra Cebollera Natural Park, because we are in collaboration with the General Directorate for Biodiversity of the Government of La Rioja, which are also associate members of the consortium of the project. And one important fact for our methodology is that in Agresta we have a strong commitment for the use of open data and open source, which in combination with our computing capacity and our skills in data analysis and modeling give us many opportunities for forest monitoring, and this is something to take into account. In particular, for this project, the data sources that we use are the Spanish forest map, which we use for the preliminary mapping of the compositional types of the study area. We also use the Copernicus data in particular the Sentinel-2 for the definition of the compositional type classification. We also use the LiDAR PNOA 2016 process with a cell size of 20 times 20 meters to make it equivalent to the Sentinel-2 pixel. And we also use some LiDAR models for our target species that we will show later. These models were previously developed for another project, which is the operational group Forest LiDAR Rioja. So the methodology for this classification of complex forests is based on 3 steps. The first step is to define or to classify the species composition. Then we will classify the vertical structure and finally the horizontal structure. The 3 main species that we define in our study area are Pinus sylvestris, Quercus pyrenaica, and Fagus sylvatica. And based on this open source data that I was mentioning before, the Spanish national map, we established the threshold of 80% coverage of these main species in order to define if the forest is pure or mixed. So with this idea, we define pure stands and mixed stands of these 3 main species. And this gave us this distribution of surfaces inside our area. We have pure stands of the 3 species and mixed stands, which are a mixture of among the 3 main species. As a second step, we chose some LiDAR parameters that are derived directly or indirectly from LiDAR, which are the tree canopy cover, the 95th percentile of point cloud heights, the canopy relief ratio, and the quadratic mean diameter. We use this information in order to start defining the forest structure. And with all this information, we made a first preliminary classification of forest types, taking some variables into account. The species composition, we define pure or mixed, depending on the level of species coverage. The stand density, if it's open or closed, taking into account the tree canopy cover, if it's more or less than 50%. The vertical structure, if it's regular or irregular, with some of the LiDAR variables. And the stand age classes, if it's thicket, pulpwood, or old growth, taking into account the quadratic mean diameter. With all this information, we define a measuring protocol that we wanted to be sure that we could survey the full variability of forest types in all the study area. So we wanted to know information about the species composition, the forest structure, the basal area, and some other variables that give us information about the 3 steps that I was mentioning at the beginning: the species composition, horizontal structure, and vertical structure. So taking all this data into account, we define 48 strata. That, in order to make it more simple and more practical, let's say, we group this 48 strata in 15. So we took the strata that were less represented with a smaller surface, or some strata that were more similar, and we grouped them in 15, just to make it more simple. But the objective of this sampling is to sample these 15 most abundant forest types in our area, and we established 3 criteria for the measuring. We wanted to measure a minimum of 10 plots per stratum and a maximum of 30, and to establish at least 1 plot every 100 hectares. So also with this criteria, we define 210 plots, always with this idea to cover the full variability of forest types in our study area. So after the field work, we were able to have a database for the classification of complex forests with all this information. We had information about the species composition. We could verify the previously identified forest types. We had information about the vertical structure, if it's monostratified, bistratified, or multistratified. The stand density, if it's open or closed, depending on the tree canopy cover. And the stand age classes, as I mentioned before, based on the quadratic mean diameter, if it's thicket, pulpwood, or old growth. With all this information, we developed the algorithms for the classification of complex forests, which have this workflow. The workflow is also divided in the same 3 steps. First, to classify the compositional type. Second step, to classify the vertical structure. And the third step is to classify the horizontal structure. I will not go into details about the algorithms, but they were developed using random forest and a decision tree algorithm called C5.0. And with this, we applied these algorithms to our study area, and we got this mapping of complex forests in our area. And based on these algorithms, we defined 94 forest categories. And after applying these algorithms or these models, we made a validation for our methodology. So we made an independent sample of 23 plots that was more or less 10% of the sample. And we established 3 levels of accuracy, let's say. Level 1, if the plot that we measure has significant differences in both the composition and the structure, and only 4.4% of the plots were in this case. The second level is if there are significant differences in composition or in structure in one of them, and 13% of the plots were in this case. And the third level is no significant difference in both composition and structure, and 84.6% of the plots were in this level of validation. So with these results, we could conclude that the use of remote sensing is a very useful source for data and allow us for the continuous characterization of complex forests, in this case, at regional scale. Thank you. This is a high-resolution methodology, which is very useful. It's a very useful tool for making forest management decisions in complex forests. And it's very important that this methodology is transferable and replicable, so can promote the management of complex forests by increasing the resilience of our forest stands. So, thank you for your
Okay, yes, there's one question. Thanks, Adrian.
Yes, at the end you found 94 types. Isn't it too many from a practical point of view?
Yeah, this is what we did at the beginning. We could also group these 94 categories to be more practical, and I don't know, maybe 15, 20 or whatever. But the application of the algorithms, taking all the variables into account, give us 94 different categories. But then it's more practical to group them, at least to make it simple. Okay.
Yes, I was about to ask the same. Now we have 98 types, and how many are enough. I don't know if you know this aphorism quote that too much complexity leads to perplexity. So probably we need to reduce a bit the number of forest types.
But it's also always easier to go from too many to
yes, for
so
sure.
So it's always better to
yes. And I also have a question, and I will give you again the floor. Is if this is in relation to the scale of this methodology, you have applied this to this Sierra de Cameros area.
Mm-hmm.
Do you think that this can be extrapolated to a larger area using maybe other kind of plots like National Forest Inventory?
Yeah. Luckily, in Spain, all this data that we use are open. So in principle, this is a methodology that could be very easily transferred to other areas. About the size of the sample, if the size is bigger, you have to make more plots for the validation and so on. But the data sources are the same.
You mentioned that you need one plot per 100 hectares?
Yeah, minimum. Yeah.
But do you test it, this threshold, or?
Well, we did it as well as I mentioned before. We wanted to be more or less practical, and we thought some of the forest types are more represented and some were less represented. So we wanted to have a minimum, even though a forest type is not much represented, a minimum of 10 plots and a maximum of 30, and then in order to be significant, for the sample to be significant, we thought about this 100.
Okay. Yes.
Hi everybody, I'm José Luis Tomé. I work in Agresta with Jorge. I think the methodology is replicable, but there is some issues in order to do it, technical issues. So, because, for example, at the end we did a classification with Sentinel-2 data. Of course, it's easier try to identify 3 different species than a very broader number of species. So perhaps if we have to do so for all the Iberian Peninsula, we are gonna find some problems in order to different some kind of species. We are working on that and we are getting better, but nowadays the methodology is replicable, but perhaps in small patches with no many species. Okay?
Is there another question? No? No? Okay. Thank you, Jorge.
Thank you.
So we can move to the last presentation before the coffee break. José Luis? Are you? Federico. Okay. Yeah. Methodology. Yes, because it's also the University of Valladolid. Also an Agresta, the methodology of 3D reconstruction using TLS and photogrammetry. So your presentation is Federico. Okay.
Thank you, Andres, for the opportunity. My name is Federico Simões. I'm a PhD student from the University of Valladolid, and I'm working mainly with LiDAR data for mixed forest modeling. Thank you. This is part of the group that was involved, and there's more also in the group. LiDAR data, it's an old, new technology. It's been around since the 60s, but in the last 20 years, the development was pretty fast. And nowadays, we can say that it's every year they release new, different devices with different approaches, and each one with different objectives. We can have LiDAR data from a phone to a satellite. And in the forest, we are mainly like Jorge just used here LiDAR data from PNOAA, from the airplane, and I'm using a terrestrial laser, a mobile laser scan. Each one of these laser scans has like pros and cons. And for ALS, for example, we have like a large area cover, but a low density of points, around 0.5 to 14 points here in Spain per square meters. At TLS, you have a really high density of points, but the time for measuring can take like 2 hours for 1 hectare if you want to do a proper way. Mobile laser scan, you can do it faster, but the point can have a bit of noise. You have more noise than a TLS. And the structure from motion, it's used with photogrammetry, and it's more accessible, and you can, but you don't have a penetration in the forest. This is a tree in the laser scan, mobile laser scan. And when I'm looking at this tree, I have some doubts about the height, because in the upper part of the crown, the density of point is low. And one of the points in this research was to see, because I'm working LiDAR, I'm using LiDAR data to modeling. But if I'm having problems with the height, if I'm missing some parts of the tree, it can be wrong. And literature review, most of the articles point some problems with height, mainly underestimating heights. But this also, one thing that I was taking account, most of the measurement was non-destructive measurement. So they was compare indirect measurements with the LiDAR. So both can be wrong. And the hypothesis was if the mobile laser scan or TLS was underestimating the heights. And if I could if I could improve my data with structure from motion. And once I'm really underestimated this height, what is the approach? What's the methodology? Should I use to use structure from motion to combine this data? And the study area was in 3 plots, in 3 martelloscopes here in Spain and 1 in Portugal. And because of data availability, I use ALS also, the PNOAA data from Spain to compare structure from motion from all the 3 plots in Spain. And from the Portugal, I use drone laser scan to combine this information with mobile laser scan and to see the results. This is 1 point cloud from Portugal with a mobile laser scan. And this one with the drone. We can see some difference, like here we have a really good point cloud in the canopy, and down in the DBH it's not well defined. And it's not so simple. It's not just to put the 2 data together and it will work. It always has like some shifting, some problems that we have to combine this information. And it's not the same as a 2D image, because in a 2D you just have to worry about X and Y, but here we have also Z. And it's millions of points to match and to merge this information. But luckily we have, sorry, this was, something happened here. But we have an algorithm that calls interactive close ECP. Sorry for this. that aligns the match all the points and maintain the structure from the points without changing. So it just minimize the distance between the points. And this is the results after processing the data. So now we have a really good point cloud in the DBH, in the ground, and also in the canopy. And here it's with structure from motion. We have the first, the upper part, mobile laser scan in Harandilia, and the point cloud created with structure from motion. As you can see, also the DBH, it's not, we almost don't have point down in the trees, but after merge, we have a really good point cloud all over. And for ALS, it's, as I said, the density of point is really low. But anyways, I used this data and I could see like if I had some improvement because we have in here in Spain. And there is no difference. But there is a strong agreement between the heights from mobile laser scan and aerial laser scan. When you do the delineation of canopy, we have a strong agreement between heights. Oh, sorry. Yeah, this was the results. There is no, I could not see underestimating of the point cloud, of the trees. The point is, the mobile laser scan has a really, in the upper part, a low density of points, but it's reaching out the top. So I can get the tree height in a good way. So when I mix the structure from motion, I have a better point cloud in the canopy, but the height is still the same. So there's no significant difference to when I mix the 2 point clouds. And when I compare the point clouds with, in some cases, with the trees, there is some, in my case, I had overestimation. What happened? My scan was around 3 meters higher than the field work. And what this means, that my point cloud was created by itself? No, the point cloud cannot just create it. So it was reaching in the trees, and because we didn't cut these trees and measure out the trees. So I strongly believe that the measurement was done not in an appropriate way. So the field data, the true data, was not the true data. And when I compare with the ALS, the mobile laser scan, and the mix of mobile laser scan and the structure from motion, they had the same agreement between heights. When I compare with my field data, I had like 3 meters difference, lower. So that was my result, my previous result now. I'm still working on my PhD, still a lot of to do this, and I'll be checking this in the future. Thank you.
Thank you very much, Federico. Any question in the room? Yeah. Miren, del Río.
Thanks, Federico. One question, because you did this study in 4 types of forests, no? In 4 sites?
4 sites, yes.
And I suppose that the forest structure was different and the height, because 3 meters is a lot. So I mean, if there are some differences between the sites concerning the accuracy of the fee of or your impression of this difference between the field measurements and the, because in some, for instance, in the example you include in the presentation, the forest was more or less open.
Mm-hmm.
So I guess that with this laser data you can estimate very well the height, but it's the same when the forest density is high. So there are differences between the four sites or not, or what?
Yes. I have these four sites, and the one I show in Portugal, it's dense and complex with a lot of different species. The one in Harandilia, it's around 450 trees per hectare with Pinus, Quercus, and Alnus in a slope terrain, not so deep, but in a slope terrain. In the north, in Valdeposa, it's 1,000 trees per hectare, so it's much more dense with a lot of quarks and small trees, small and really dense. And the point is, after I'm studying, I was searching more in the Harandilia area where I have the data. And after the Portugal data, we get the field data soon. And we are doing, again, the Marugan and Valdeposa, we are measuring the positions and the tree height again, so we can be sure that the height was well done. Unfortunately, we cannot cut any trees in this site, so we have to do indirect measurements also, but we're trying to get these like in different seasons, like leaf off, leaf on, and try to see and scan in different, so we can understand how to use and how to get better data from this kind of complex forest.
Thank you. We have another question. So Luis from Agresta.
Thank you. Federico, from your point of view, which is the best way to do the work? Which is the best combination with taking into account the accuracy and the cost of the work?
Yeah, like I really like the mobile laser scan data. I think only with mobile laser scan it's enough. If you do it in a proper way, you don't need to merge with another point clouds. And if so, if you want to have a better canopy delineation, if you are studying the canopy, the best way it's to use a LiDAR mobile and a LiDAR aerial with a drone. And for this, you must put 3D targets. So after you can combine these 3D targets and see the shifting from only from these targets. Because when you are doing processing like millions of points, to match all these millions of points is really hard. But once you get 3D targets and you make a matrix table of this shift, and you can apply for the whole point cloud, and it's faster to do it.
My name is Susana Barreiro from Lisbon. I provided part of the data, where I am still to provide part of the field data for Fred to finish his assessment of LiDAR. What I wanted to ask you is if it was useful, the 3D targets that we placed there, for you to merge both
yes, exactly, because
could you use them? Were they useful?
Yes, because as I was saying, when you have like 3D targets, I can work only with the 3D targets. Instead of working with the whole point cloud, I use just in Portugal, they put some spheres.
I have pictures in my presentation.
Yes. So with this, I can combine one sphere from one point cloud to another one, and it's maybe just like a few thousands of points, and it's faster. So it's better to do like this than the whole point cloud.
Okay, so soon you'll have the data. You don't have it yet because you complained so much about the quality of field data in previous Martelloscopes that I had the guys remeasuring and checking every height, so that's why it's taking longer.
Yes, it's for me it's a bit complicated to say that the true value cannot be true because I know like when we are in the field, sometimes I'm with a clinometer or a vertex, one measure one tree and the other one goes there and measure the same tree with a bit different. And this, if you are working all day long and all the time with measurements of height, you get really good on this. But if you are doing this once in a month, once in a year, for sure, problems can happen.
Yeah, let's hope that doesn't happen with our data. Thank you.
Thank you, Susana. Any other question? No? Okay, thank you very much, Federico.
So we reached the end of the first session in the morning. So we are going to stop here, stretch our legs, have the coffee break, and allow also the remote colleagues to have some rest. So we stop the video here, I guess. Yes? And now.
¿Qué pasa si el desierto está a la puerta de casa? Si el desierto está a la puerta de casa, la frontera es el bosque.
Dentro de los distintos tipos de bosque podemos encontrar los bosques complejos, que son aquellos que o bien tienen varias especies arbóreas o varias clases de edad y diferente tamaño. Con el calentamiento del planeta, pérdida de biodiversidad, cambios de uso de la tierra, los bosques complejos son una oportunidad y un seguro. Infinidad de estudios han demostrado que este tipo de estructuras son más resilientes y más resistentes a los efectos adversos de distintas perturbaciones. Pero no solamente desde ese punto de vista son importantes, desde el punto de vista económico, de servicios y bienes que nos proporcionan a la sociedad, este tipo de bosques lo hacen de una manera más eficiente y en algunos casos en mayor cantidad que otro tipo de estructuras más simplificadas.
Al tener o bien varias especies o bien varias edades o varios tamaños, pues permite que la provisión sea más diversificada. La ganadería, la producción de madera, con la obtención de setas o con la obtención de resina, llegado el caso.
Pero hay otro tipo de servicios que también son importantes. Están los servicios de regulación, puesto que intervienen en los ciclos de los nutrientes, del agua. El bosque, digamos que es un actor clave en todos este tipo de ciclos. Y luego están también los servicios culturales, socioculturales.
Hay un componente cultural muy importante en los bosques que muchas veces se nos olvida y que muchas veces estos bosques y la parte del paisaje está muy imbricado en la cultura de un territorio.
Son patrimonio de la población y son patrimonio de las sociedades.
Entonces, tenemos que ser conscientes de cuál es la importancia que tiene la naturaleza para nosotros, que nos proporciona, ponerla en valor y en base a conocerla, pues poder utilizarla de la mejor forma posible.
El principal objetivo de COMFOR-SUDOE es generar una estructura de bosques complejos que puedan servir de modelos, de ejemplos para promover este tipo de bosques en la región SUDOE, que es un espacio del sudoeste europeo.
Son las regiones en las que estamos viendo que el cambio climático está produciendo cambios más visibles en estos bosques.
Primero hay una parte de interdisciplinariedad, entonces de ofrecer una mirada desde diferentes disciplinas y de diferentes campos de la ciencia sobre los bosques complejos y entender cómo la complejidad es un valor en sí mismo, ¿no?
Para fomentar, conservar y favorecer este tipo de bosques complejos, en el proyecto desarrollamos una serie de estrategias con los que pretendemos al mismo tiempo presentar una serie de herramientas que puedan ser después utilizadas por los gestores.
La primera es una estrategia de entender, de conocer qué es lo que es el bosque.
Tenemos una serie de estudios observacionales, es decir, parcelas de seguimiento y de investigación, en los que lo que hacemos es seguir la marcha de los bosques como fuente de conocimiento. Y ahí el proyecto está llenando un hueco que había en relación con la falta de ejemplos de investigación en bosques complejos.
Para ello hemos desarrollado tipologías de distintos bosques complejos, utilizando tecnologías tipo láser o incluso el servicio Copérnicos de la Unión Europea. Por otro lado, tenemos una estrategia de gestión y más concretamente de transformación de bosques monoespecíficos a bosques complejos. Y no solamente transformar aquello que ya existe, sino también para desarrollar nuevos bosques complejos. Finalmente hay una estrategia socioeconómica.
Uno de los aspectos fundamentales dentro del proyecto COMFOR-SUDOE pasa por la valoración del capital natural o la valoración de los beneficios que el bosque genera para la sociedad. Está basado en una metodología desarrollada por Naciones Unidas para tener un proceso normalizado y sistematizado de qué forma se puede incorporar la naturaleza en el modelo económico actual. La herramienta que se va a desarrollar dentro del marco del proyecto COMFOR-SUDOE podrá ser utilizada por diferentes tipologías de gestores privados y gestores públicos.
En la parte social es estos aprendizajes de qué es el bosque para las distintas personas que viven en distintos territorios, porque hay diversos territorios dentro del proyecto, y luego a futuro lo que vamos a hacer es llevar todo esto a decisores políticos, a gestores.
Alcaldes, alcaldesas, grupos de desarrollo rural, personas que gestionan reservas de caza, cazadores, ganaderos, ganaderas, agricultores, agricultoras. La idea es construir una guía de cómo incorporar esa perspectiva de los actores sociales en la gestión forestal.
Uno de los avances que hemos encontrado en el proyecto, y la verdad que estamos muy satisfechos, es el grado de implicación de los distintos actores del territorio en las actividades del proyecto.
La investigación forestal requiere tiempo. Desde que la ciencia forestal está sistematizada a raíz del siglo XVIII, que empiezan a acumularse observaciones y empiezan a extraerse los primeros datos, nosotros hemos cubierto una fracción muy pequeña de la longevidad de gran parte de las especies.
Es un proyecto a largo plazo, esperamos seguir teniendo avances, pero creemos que los bosques complejos van a formar parte de la agenda política y de las tomas de decisiones en los próximos años.
Okay, thank you very much. We're going to resume this symposium, this meeting. So now, next is our keynote speaker, Miren del Río. He will talk about temporal stability and productivity in monospecific versus mixed stands. So Miren, the floor is yours.
Hello. First, I want to thank Andrés and all the consortium of the COMFOR project for inviting me to this symposium. That is very interesting. Andrés asked me to talk about the temporal stability of productivity in mixed stands. And so what I will present here is the result of 2 studies we did with some plots along Europe. And the structure of the presentation will be the typical of a study, so with introduction, methods, and results. So it's not really a keynote talk. Why? First, I want to clarify what is temporal stability of productivity, because the name, of course, says what is the concept, no? So we want to measure the variability of productivity in forest stands, and usually in most of the studies, the temporal stability of productivity is analyzed with inverse of the coefficient of variation. So it's simply the interannual, or maybe the period could be different than annual, variability of the productivity. And why this is important? Well, the temporal stability is part of it's a component of the ecosystem stability that often is described by the different attributes like resistance, resilience, and the temporal stability is another one, no? How is this variability with the time. And this temporal stability of productivity is important in forest systems because the productivity is a key indicator of forest functioning linked to many ecosystem services. In this picture, I use the main criteria, the sustainability concept in Forest Europe, and the size of the arrows indicate the link between the productivity with these different functions, and of course it's more linked to the production and the carbon cycle, but it's also related or reflected indirectly other ecosystem services. Well, there are several studies that show that temporal stability of productivity is correlated positively with the species richness. There are much more studies in grassland communities, but also there are now some studies that also demonstrate that the species richness increases the stability of forest productivity. No? Like in this figure, this is a study of 10 years ago, more or less, that demonstrate this increasing patterns in most of the cases. But there are not so many studies on the topic. The hypothesis behind this positive effect of species richness is the niche complementarity that can increase this productivity, so increasing the mean of the productivity and influence in this way to the coefficient of variation and the inverse of the coefficient of variation. And also the niche complementarity that says that the species can capture and use the resources in different ways. And also the insurance hypothesis that says that an ecosystem can be more stable with many species because if it is mine, because if one species fails, the other can cover the functioning. No? And also there are some studies that indicate that the pattern of this species resilience effect on temporal stability can change depending on the scale. So that in most of the studies, there is a positive effect on the community level, that it will be at a stand level in the case of forests. But the results at population level, that it will be at the species level, are unclear. So there are contrasting results in the literature. But this population level can be very important in the case of forest system with few species, no? Because if the diversity triggers some instability for one species, can be that this species can disappear in the long term. So this is important, especially in forest system with few species. There are also some studies focusing on the drivers, so what is triggering this temporal stability, and I don't know. So it should not be like this, but the synchrony between species growth is generally the most relevant pattern, the most relevant factor that is affecting the temporal stability. It is not so, but it can be related to the different the species-specific growth response to environmental variables, but also the species interactions can change this response to environmental variables and trigger this asynchrony that finally stabilizes the productivity. Regarding overyielding, that it could increase the mean and in this way increasing the stability. There are also contrasting results in forest systems. Some studies find that there is an effect and others that not. And in forest systems, there were very few studies focusing on the environmental factors, like how the effect of the species diversity influence on temporal stability in different climates, so in different sites. So there was not enough information. And also, but in other communities that different to forests, there are some studies that indicate that this effect changes with environmental factors. And also, in some studies, they indicate that the species dominance is also important, so that in some systems it's more important the stability of the dominant species than the species richness, and it can also be important. Okay, in the study I am going to present now, we focus on two species mixtures because this is relevant for forest management. We have many areas where we have mixed forests formed by two species only. And also it's important because from a management point of view, it's more or less easy to transform one specific forest into a species forest. So it can be something important for this transformation to more diverse forests. And our question was to what extent mixing two species can increase temporal stability. You saw, if you remember this figure, so there is an increasing pattern that is more or less similar to what's found for productivity. So at the end there is a saturation, no? When they increase in the number of species, but it could be that in mixing two species is not so relevant because the effect could be low. No? This is one of our questions. Also, we wanted to know if there are differences at the stand species and tree level in this effect of mixing two species on temporal stability. And also we wanted to identify the main drivers of temporal stability, including climate conditions. So we didn't include in our hypothesis the species dominance, because the data we have for the study, I will show you later, are mixed. In the case of the mixed forest, they are more or less, they are only 2 species and more or less balanced. So the difference between the species proportion of the 2 species was not so high. And we thought that we didn't have enough variability for this. And in this picture, you can see our hypothesis, that is that the climate is influencing the word yielding temporal stability, but also could be directly or indirectly through species asynchrony, over-yielding, and that over-yielding can influence temporal stability of productivity in mixtures. And we also wanted to test if there is any difference or the effect of the species asynchrony in the monocultures and the species asynchrony in the mixtures. Because if they have different effect, they can explain different aspect of productivity. We can assume that the species asynchrony in monocultures is reflecting the species-specific response to environmental variability, while the species asynchrony in the mixtures can be also influenced by species interactions, so they can be different, no? And we wanted to study this aspect. And related to this species asynchrony in monocultures, we define also the additive effect that shows the reduction in variance just by adding 2 species. So in this additive effect, what I will explain later, but we want to see what happens if using the monospecific stance, what could happen if you mix them, but if they behave in the similar way than in monospecific stance in the mixture. I will explain later, so I think it will be clear. So for this study, we use 3 transects of triplets, a total of 87 triplets, 32 of Fagus sylvatica Pinus sylvestris, 35 of Quercus and Pinus sylvestris, and 20 of Pythia abies and Pinus sylvestris. In each triplet, we have 1 plot with the mixture and 2 plots with the respective monospecific plots. And you can see the distribution along Europe, and also you can see the climate variability we are covering with our data in the 3 transects. Well, we did the typical inventory data in the plots, and we reconstruct the basal area increment for 14 years. And also we use the climate data for the same 14 years to study the temporal stability. The temporal stability was estimated, like I explained before, with the inverse of coefficient of variation of the productivity. We assume that the basal area increment is reflecting the productivity. We prefer to use the basal area than the volume because we have a more direct measurements for the past with the height. And we estimated over-yielding with the ratio between the basal area growth in mixed stands compared to the basal area growth that could be expected using the data from the monospecific and the species proportions. So the basal area increment expected is what we could expect if the species grow like in the pure stands. For the study the asynchrony in productivity, we use the correlation between species, and so the correlation is the synchrony, and the asynchrony was 1 minus correlation. If some of you are familiar with this topic, there are other ways to estimate the asynchrony, but for 2 species the correlation shows similar results as with other approaches, so we use the correlation. And the additive effect, we estimate this with the temporal stability expected from the monocultures. Also, like with using the basal area increment, the expected basal area increment and by year, and then calculating this stability, the inverse of the coefficient of variation. Well, now I will present the main results and some discussion. I will go by steps. First, focusing on the word yielding and temporal stability at the stand level, we found that in the mixtures, there was a higher level of productivity, so there was over-yielding, and also a higher stability than in pure stand. The mean value is around 6% in terms of over-yielding, and in terms of temporal stability, 12%. So in the mixture, we have a 12% greater stability than in the monocultures. But as you see in the figure, there are some differences between the species compositions. The greater effects were found for pine and beech mixtures that you see in this case. The green arrow indicate that the differences are significant, so the mixture was more stable than the two monospecific stands, and also the over-yielding, that is this green point, it's the highest comparing to the other composition. In the case of pine and oak, the mixture was similar than to the oak species, so the oak monoculture were also stable, but the pine was less stable than the mixture and the oak. And in the case of spruce and pine, the difference between the mixture and the monoculture was only significant for spruce, but in the two cases, it was greater in the mixture than in the spruce. So looking at it, we see that the species traits are also important, the composition of the mixtures. For instance, for over-yielding, the more different the species, the greater the difference. But of course, we cannot test this because we have only 3 mixtures, but it gives some ideas. So what we see that comparing with other studies, focusing on over-yielding, we can see that in general, if we mix 2 species, we can get more efficient systems in terms of productivity, and it disagrees with other studies, like this a table that is compiled in the book of mixed forests by Pretz and collaborators. But we didn't find significant over-yielding for spruce and Scots pine, but we cannot say with this that they are not over-yielding because we find in other studies that pine mixtures can be also more productive than the monocultures. So we need more studies to do a general conclusion. What we can say is that in the 3 cases, the stability of productivity, the temporal stability of productivity was greater. So we can say that with 2 species we can stabilize somehow the productivity, and these results indicate that there can be both the complementarity and also some buffering effects by the species mixtures. Concerning the temporal stability at different levels, we did this study only on pine beech transect. This was a previous study than the other one. And in this case, we found that the temporal stability was greater at the stand level, but when focusing on the species level, there was not this positive effect. So the temporal stability by a species was similar in the mixture than in the stand, than in the pure stance. And focusing on tree level, we found that in the case of pine, the temporal stability was lower in the mixed than in the pure. So something is happening here. There are other studies based on modeling that indicate that on long term, there can be a possible negative effect of mixing species at the species level. That means that one species can be damaged by this mixture and reducing its stability in terms of productivity. I think we need more studies on this topic because it can be important for forest management. And probably in our case, in our study, we have a too short period. So we know that for the system are growing slow. So we need more longer series to do this analysis. And also, in our case, the control of mortality was not perfect. So we tried to consider the mortality, but it was not so well controlled. And regarding this, I want to show some new results we have from the triplets of pine beech that we measure again. And what we found is that the mortality is greater in the mixture than in the pures, and especially in the case of pine, that we could relate with this lower stability at tree level. And it means that the part of the over-yielding that we found in this pine beech mixture is lost by mortality. And it can indicate that it can be a good opportunity if we thin this mixed stance, we can better use this over-yielding than if we don't manage them. Regarding the drivers, we found interesting results, and this one is that temperature is affecting temporal stability directly in a negative way, both in monospecific and in mixtures. So it is indicating us that with climate change we can have more unstable forests, not only due to disturbances, but also the inner productivity. And we found that the precipitation effect was variable depending on the species composition. I didn't include here the patterns, but in the case of mixture, that is what is shown in this diagram, the precipitation was not directly affecting temporal stability, and the climate didn't have a direct effect of over-yielding. Other studies and also meta-analysis, like the one done by Hervé, indicate that the precipitation that the over-yielding is increasing with the precipitation. But in our case, we didn't find this direct effect. Maybe I will relate it indirectly. Oh, sorry. Discussing a bit these results, this negative effect of temperature was also found in other plant communities and in grassland, and in this study by Valencia and collaborators that include different plant systems. We found that the effect of the precipitation is indirect through the asynchrony, because as you see here, there is a positive effect of precipitation on asynchrony between species. And we can say that that as we have a positive effect of mixing species can mitigate somehow the negative effect of temperature. Sorry. Regarding the other drivers, we found that both the asynchrony in mixed stance has a direct effect on temporal stability of mixtures, and that the asynchrony in monospecific stance influence on the asynchrony in mixed stance, so that they are somehow related, as I explained before, but they are different, so it means that there is also some variation due to species interactions. And also it's important that the additive effect can explain, that this is a statistical analysis, can explain a large part of temporal stability. So, and it means we can interpret this that simply by this effect of the different intrinsic variability of species, we can have an increase in the temporal stability simply by mixing two species because they are different. No? And this is important and agrees a bit with the different, with the result also that we found this positive effect in the three mixtures that with the species with different traits. Regarding the asynchrony, we found also that asynchrony was positively related to overyielding. It was also found in other studies. So we can say that the asynchrony has an important role in forest functioning because it influences on overyielding and temporal stability. But we found also that these two effects were not related. So the plots that have, so that they were not correlated. That is also agreed with other studies that says the same. So we can have some plots in which we have overyielding but not better stability. Also, there is some variability in the results. And as a conclusion, the key message is that when we meet two species, we can have a higher level and more stable productivity. That, of course, it will depend on species traits, but on average, we can, like a rule, we can say that. And from a management point of view, that adding only one additional species to monocultures, we can get a lot of benefits that I think is important for forest management. That missing species, we can mitigate partially the negative effect of temperature on temporal stability, and also to consider that the species asynchrony is an important characteristic in forest ecosystem functioning, so we need to better understand this between species asynchrony. And that is all. Thanks. And also thanks to all the co-authors of the studies and the people contributing to the triple task because it was the result of many people.
Thank you very much, Miren, for this nice presentation. So once again, I open the floor for questions. Yes, we have one here. Susana Barreiro.
Thank you. Thank you, Miriam. Going back to one of your last conclusions, that adding one species will create more stable systems. What is the proportion of that addition? Is it 50-50? If I wanted to make a system more stable by adding one additional species, in which proportion should I try to add the second species?
Yeah, interesting question.
Difficult
not so easy to answer. In our cases, we have proportions more or less that the lowest is 25 or something like that because we look for some contrasting results. But you saw also that there are a high variability in the data. So we found significant effects, but also variability. So it's not so easy to say. And of course, depends a lot of the system, of the main objectives of the stands, and so on. So.
And the 25% that you referred
in basal area.
That's what I wanted to know. Thank you.
We have another question here.
Thank you. Just one question. Your indication of the effects of temperature and precipitation, they are based on the observations, on data, or it's results of some modeling?
The climate data? You mean? We in most of the cases, they are from observational weather stations. Yes.
And you try already to implement it in a kind of a modeling framework or kind of a process-based model, or it's basically statistical.
So this study was mainly empirical, so just relating the things, but based on real data.
Are you trying to get to a kind of a more process-based model, or?
It could be interesting. If I am not, so I don't have so much experience in process-based model, but it could be tested.
Thank you.
Thank you. Any other question? Okay, yes, I just what curiosity. Federico. Okay. My curiosity can wait.
Sorry. Miriam, we are facing in Brazil some problems with droughts and eucalyptus. Many areas, they're dying like 50% of the areas. And if I want to suggest or to give a starting point of mixing, because it's not from the culture there, it's only mono-specific species, eucalyptus plantation or teak or magnus in my area. How can I start to find another species? Where should I start to add a new species to make the commercial plantation more resilient?
So I am not expert in this area of. I only read some papers on eucalyptus plantations that, for instance, they try to mix eucalyptus with some fagaceas to benefit from the nitrogen fixing, and the effects are, of course, always site dependent, because if there is not nitrogen limitation, the effect is not so strong. So my view is that I don't know Brazil, so I cannot. But focusing on the Iberian Peninsula, that we have also eucalyptus plantation, and so my personal view is that if we want to get high productivity, so maybe monocultures are not so bad, but there could be also alternatives. It should be something that the enterprises and the forest owners accept. But maybe we can also play a bit with the spatial mixtures or not. But I think it's a challenging question, no? How to diversify the plantations, because in fast-growing species, we want to have a productivity very quickly, and if in the mixture, if the species don't grow at the same rate, you have to manage a lot, because if not, one species will dominate the other. So I don't know, but and we are now starting also in another project. We want to study the interaction between genetic genotypes. No? And maybe this in eucalyptus could be also interesting. What happens when you mixture, because in many cases I know that, for instance, in Brazil, you use a clone in many hectares, and the risks are also very high with this, because you have higher risk with the disease and other factors with using only one clone. And it could be also interesting what happens when you mix genotypes, because probably if the crowns are different, if they grow different and respond differently to the climate, we could also get some benefits mixed in genotypes. But I don't know.
Any other question? Yes.
Thank you so much for the presentation. My name is David Alvarez from Ecoaxa. We're working on ecosystem services in natural capital, as I'll tell you till this afternoon. My question is, would it be possible this methodology to be adapted for any other ecosystem services in addition to what you mentioned?
Yes, of course. It could be interesting, and we need the data because you need to have a temporal series. If you want to study the temporal variability or temporal stability, you need, I think, a long series. And this is the main problem, no? That we don't have. And if you want to relate to the climate, but you can apply, of course, this, and it's also relevant.
Okay. Yes. Well, my curiosity was
The
something
same.
similar. Yes, but more related to ecosystem processes. For example, temporal stability of regeneration. For example, could we use this way of calculating temporal stability for that, for regeneration?
Yes,
Yeah,
I think depending the process you are studying, for instance, in the case of regeneration, and depending on the period you are studying, maybe you need to include other covariables that can influence more. But
okay. Someone in YouTube? No? No in the chat? So thank you, Miriam. Okay, so next in the line is Benoit. He will present the Formix network. Very interesting outcome from the project. Here it is, I guess. Yeah. Thank you.
Thanks, Andres. So maybe I should start introducing myself. My name is Benoit de Guéry. I'm a forest engineer from France, working at IFC, the European Institute of Planted Forests. And I will present to you the Formix network, that is a network of experimental plantations that has been initiated during the COMFOR project, taking advantage of all the work done on complex and mixed forests, and that is meant to last after the end of the project. So the Formix network is based on the same principle as the TreeDivNet network that you may already know, because it's the largest platform for research on a relation between tree species diversity and ecosystem functioning in forests and worldwide. So this network is gathering a lot of data and also some smaller networks in different countries. And so I think one of the ambitions of the Formix network is to be a kind of Southwestern Europe contribution to the TreeDivNet network. And so we will have to comply with the TreeDivNet standards, but we want to keep to emphasize on the specificity that will be to balance the interest of this experiment between the scientific interest and the interest of forest managers and owners. And that's why the idea behind my title, that I try to write a bit catchy, to reconcile productivity and research in a long-term network of experimental mixed plantations. And so the challenge behind that is, of course, to implement trials that are both valuable for research through the collection of data and different comparable sites, but also that the management can be operational upscale by the forestry industry. So, and that's why reaching tree species diversity through the plantation of mixed forests is a good combination between those two objectives. So this was this initial idea, and then here is how it was built. So we started by formulating some baselines, like the objectives, that is to better understand the effects of mixtures on forest productivity and resilience to climate change. And as I've said, to reconcile scientists and forest managers on the same project. We've written a common charter with principles that the trials should follow to make it possible the comparison of the results between the different experimental plantations. I will show you this charter later in the next slide. And this is, of course, a call for cooperation. This network has been initiated by the COMFOR project's scientific partnership, but it will be open for any organizations willing to adopt the same principles and wanted to work with us. So you're very welcome to join us. So here are the 6 common principles that we would like to follow to have a common standardized trials. The first one is to, of course, select species to mix together, but species that can be relevant for the local forestry sector. We suggest to limit mixtures to 2 or 3 species mixtures. More species would be quite complicated to manage. And also try to associate, if possible, broadleaves and conifers, because it is said to be the more, the best possible association in terms of complementary traits. Each species must be planted as monocultures to act as control for the mixtures. So this is important to characterize the effect of mixtures compared to monocultures and characterize the negative or positive effects on productivity, try to measure potential overyielding and try to characterize the different overyielding, whether it's like a relative gain of productivity or maybe an absolute gain of productivity compared to monocultures. We would like also to include a test of plantation modalities to optimize productivity and revenues. This can be by playing on the tree densities when planting, but also on the different proportions of the species mixed together. So maybe we could better answer the Susanna's question to the last presentation. We also suggest row-wise or strip-wise planting to facilitate silvicultural operations. And also, you will need to provide a large experimental area to allow realistic cost-benefit calculations for the treatment tested. So this is the common basis, and then you have room for adjustments to local conditions. So the choice of tree species should be adapted to local conditions based on the type of soil, the current and future climatic conditions, and the relevance to local stakeholders and industrial expectations. So IFC is in charge of coordinating this network, and we are working on creating a website to gather all those informations and a kind of protocol to design step by step your own experiment, a theoretical protocol. But here is just an overview of a theoretical design for joining the mixed network. I will start maybe with the big picture here. You have the experiment should be made of at least 3 blocks, with each block containing all the tested modalities, and then the other blocks are like a replicate with a randomized distribution of those plots. If we zoom in one block, you have here, as I said, all the tested modalities with the monocultures, 2 species or 3 species mixtures of the species, and if you want some variables with the planting densities or proportions. And if we look at one plot, what is important for us is to be able to measure at least 30 trees per species to have enough robust data. And in the core area, in order to avoid the edges, the effect of edges. So you will need to be aware of that when designing the size of your plots. So this is the overview of one possible design, and I will show you how looks the trials that has been already implemented. And very quickly, the different data that we want to collect. Nothing special here, just survival rate, some dendrometric informations like the height and the diameter. the tree health, information on tree health, so if there is biotic or abiotic damages. Also, the management cost or income, and every other optional data that we could have time to collect. Okay, so yes, I wanted to show you what is the initial state of the Formix network as we speak. So here is a map with the location of 6 sites that has already been planted in our 3 different countries, Portugal, Spain, and France. So we have, for now, 3 locations here in France, 2 in Spain, and 1 in Portugal. And I'm just thanking our partners for having installed those trials, and all the funders and local communities that accepted to establish those trials. Here is just an overview of the diversity of tree species that were planted and that will be studied in the years to come. Tree species per experimental site. What is interesting is that there is some redundancy between the tree species installed, like, for example, birch, that is present in 3 sites, Pinus pinaster maritime pine in 3 sites also, or Quercus rubra. And so this will allow for some comparison of the results and a more robust analysis of the results. And I wanted to go quickly in each of the planting experiments so that you can have a better idea of how it was made and what are the information for each site. So let's start with a first experiment, and actually the largest experiment of this Formix network that has been implemented by INRAE near to Bordeaux here. And it includes a test of 6 tree species, including 3 conifer productive species and 3 broadleaves secondary species. And in those coniferous productive species, you can find, of course, the maritime pine that is usually planted as monocultures on nearly all the Land de Gascogne forest. So it was important to test some diversification of these monocultures of maritime pine with the introduction of other species. There are 2 tested variables, 2 initial densities and 2 proportions, and we ended up with 32 plots that are multiplied by 3 blocks. And here you can see the different modalities, and I haven't included the monocultures here. Here is how it looks. If you were there at the previous General Assembly, you may have visited this site, but here the blocks are really close, and here is how it looks like. Next site that has been also established by INRAE, but in the Massif Central, so in the middle of France. Here, the trial is a bit smaller, with 3 tree species studied, including the Douglas fir, that is also an important productive species in France, and that is usually planted as monoculture. So it was important here also to bring some diversity and test some other tree species associations. Again, 2 initial planting densities and 2 proportions. And here what is interesting to say is that the blocks are distance of nearly 40 kilometers, because of course you're dependent on the available area that you can find. So this is to show you that it's okay to, you of course need to adapt to your available areas. Next, going back near Bordeaux, is an experiment that has been planted by the National Office of Forest, the French office, that is in charge of managing the public forest. And again, a test on maritime pines, but what is interesting to show is that they took advantage of several municipalities interested in this project to plant 7 replicates of the same here experiments. So there is a lot of redundancy of the data. Next is an experiment that has been planted by Niker in the Basque Country, and with 3 species studied, 1 coniferous and 2 deciduous species, and a test of the planting densities. And here, I think the main productive species that is studied is a hybrid larch that is diversified by deciduous species. And here you can see that it's in a quite sleepy area. And finally, Susanna will maybe talk a bit more about this, but Portugal, in cooperation between ISA, the Institute of Lisbon on Agriculture, and a company Altri, established mixed plantations of 3 tree species, mixing the eucalyptus, that is of course the main productive species in the area, with other coniferous and deciduous species, and ended up is in this kind of picture. So I'm missing some data for the Spanish trial, but I know that they are planning on planting another experiment in Spain. So this was an overview of the diversity of plantations that has been made in the FORMIX network. And I wanted to end with last slide to again speak about the opportunities of this new research structure. You are of course very welcome to join the network and establish your own experiments using our protocol and principles, and we can offer our help to co-design your experiments if needed. The FORMIX network will later apply and hopefully join the worldwide 3DNet network, and we are open to any collaborations if research teams want to take advantage of the existing experiments to run additional studies, to sample other data, and so on. So thank you for your attention, and yeah, if you have any question, please ask.
Thank you very much. We are a bit behind schedule, so you have any question? Just one question. Probably there will be more questions now because we are going to change a bit the agenda. Now Felipe is going to present the online presentation because he is also talking about the mixed species plantations in Spain, as you mentioned. Yeah. So probably after his presentation, probably we can have more questions. Thank you.
Okay. Good morning. Can you hear me?
Yes.
Okay.
But I don't know how to. Eso es que no sé. O sea, yo lo oigo, pero aquí no está como desconectado.
But I share.
Okay, now we can see you. We can see your presentation too. So it's okay. The floor is yours, Felipe. Thank you.
Okay. Thank you very much, Andrés. Sorry to be not able to be there today because I have class this morning, but tomorrow I will be there, and I hope I can stay with you for the morning. So my presentation focuses on different experimental designs that we are developing at the University of Valladolid related with the early development of mixed forest plantation. Part are included in the FORMIX structure that Benoit just explained, and I will insight in some particular cases. Another are Nelder wheels that we established in different projects, and now we are analyzing from the perspective for the early mixed forest plantation.
So as Benoit told us before, there are for mix 6 common principles that mainly we can summarize in a twofold concept. We have a common principal condition and a common principal framework, but adjust to local condition. We have different species and that are adapted to the local condition and also relevant for the stakeholder or in every area. In our case, as Benoit told us before, we have a plantation in Montija de Arija in Burgos, in northern Spain, where we are testing only one density and one spatial arrangement with 3 species. In that case are Pinus sylvestris, Pinus nigra, and Betula alba, with the 7 combination, the 3 pure plantation, the 3 double mixture, plus the triple mixture in buffer. It was established last year under this project, COMFOR-SUDOE, and with this arrangement you can see here. So this is a general overview of the area. I don't know, I can hear someone. I don't know if I'm myself or someone who is speaking, but I have a return of the talk. So and here, so we have 3 blocks, 3 different blocks where we establish these 3 species in the 7 different arrangement. So and this is one of the outcome of this project. Here you can see the 3 blocks in a plot of 50 by 50 meters with 15 meters buffer each one in the area. During COMFOR-SUDOE, we designed a new one. This new one is in central Spain, in Extremadura, in Jarandilla, where we test 3 different spacing with other 3 species, are Pinus pinaster, Quercus suber, and Quercus pyrenaica. Hopefully, by the end of this year, it will be established by the regional government of Extremadura that we are connecting with them. So at the end of the year, hopefully we will have 2 4-mix sites under the University of Valladolid scope. Benoit, I will let you know all the details about this. Beside that, we have our Nelder wheel network. Under this Nelder wheel design, that was Nelder works in the 60s. They developed this type of plots to incide on the spacing for crop plantation, and that we use for forest. It was extensively used in the 60s and 70s and then was abandoned due to the difficulty to analyze the data. But now with the programming and the statistical capability, now we are able to analyze such analysis. So in that way, this is from a popular journal here in Spain. They were very surprised as in Japan, trees grow in circles and nobody can explain. But in fact, where that Japanese forester, they planted Nelder wheel in that area in Japan. In our case, we work with Reinforce. Reinforce was a project led by the IFEC in Bordeaux, where Benoit is working, where we established a set of arboreta, and close to each arboreta, some demonstrate area paired with the arboreta. In our case, the demonstration was focused on Nelder wheels. That is different that people did in Portugal, France, or UK. In our case, plantation was in 2012, and we established a total of 5 different Nelder wheels at that time, with different combination. Always 2 species: Pinus sylvestris, Quercus pyrenaica, Pinus sylvestris, Pinus pinaster, Quercus ilex, 2 Eucalyptus nitens that are the same species but different clones, resistant or not to Mycopharella, and finally Pinus sylvestris, Pinus radiata. All this extensive network now, after 11 years, are ready for the next year to conduct a full analysis of all them. But 1 year later, we established another one very close to Palencia, where we planted Pinus alepensis and Pinus pinaster. I don't know if I told you here that we established always normally 4 wheels. Each wheel was divided in 4 quadrats, 1 quadrant for each species, and the other 2 quadrats with a combination of the 2 species in a 60-80%. And then we rotate between the 4th quadrant of the quadrant of the wheel to have that all the combination are in every orientation. This is the standard for these 5 sites, but in Calabazanos we established a new one, a 5th one, that's for destructive analysis. So in this picture is for 2022. So here is the installation of these nether wheels that are lower cost. So we established with the total station, the position of each tree we planted to get all the spacing. And finally, we have that distribution. We have planned another replication in Jarandilla with Pinus pinaster and Quercus suber that hopefully will be done also this fall. And it will be paired in the same area as the previous plantation and described. Our first studies or insight are published already in forestry, where we analyze the biomass production, biomass allocation, and also the growth and the early survival, because we have in Calabazanos a lot of problem with survival due to the rabbits that was a pest there. So I think that is the things I want to show you about the different actions. So for one side, we participate in the for mix structure with the other areas. In total, 7 when we finish this in Jarandilla, but we have this another network or 6 + 1 planet nether wheels that it will be fully available by the end of the year. Thank you very much. I'm here for any question you can have.
Because you mentioned this for biomass production and for good production, is any other possibility to change one of these productions when you design the mixed plantation for the 4 mix network? Or because as far as I understood, you have for biomass production, which basically is for energy maybe, and for good production, which is for timber. So I'm just would like to know if there is a possibility to modify these requirements to join the network.
I mean, yeah, it is quite flexible, but the idea was to propose some mixed species plantations that are relevant for the forest managers that are usually managing pure stands for wood production. So that was just to demonstrate that you can still produce a lot of wood or timber or store carbon while mixing with other species. So this is why we focused on very productive and fast-growing species, mainly conifers at first, and then combined with other species which can have other uses.
For example, cork.
Yeah.
Not only biomass, but also
could be cork, could be yeah. For example, in Portugal, they have associated eucalyptus with a fruit tree, which is the Arbustus unedo. Yeah.
Okay.
So we are quite flexible.
So I want to say that it would be nice to have an additional oak plantation, because in Jarandilla is planned to use quercus sugar, so to have another site to compare in Portugal, it would be great.
Okay, so we don't have any more questions, not on the net. Chat is quite, they are very shy. Okay, so we can move on. We are really behind the schedule. So I think it's could be my turn, and then Susana will finish this, Cristobal will finish this block. Yeah, okay. So now I will present the other network that has been created in COMFOR. Here it is. So, as I mentioned in the first presentation, we aim to increase complexity in plantations, for example, or reforestation, old reforestation, and also to create new complex structure by planting mixtures. So, if you remember two previous slides that I saw you, society needs from forests more resilient structures, more ecosystem services, and also more social acceptability. So if we believe or we agree that the in this case plantations or any other more specific reforestation or afforestation, here in Southwest Europe we have millions of hectares of afforestations, more specific afforestations with pinus species. So if we accept that this is less resilient and they provide less ecosystem services than other structures, then we need to transform this pure stands into more regular pure stands into more complex structures. So we are not going to invent anything. In silviculture, we have lots of tools to do this transformation. We can apply shelter wood systems with preserved trees. We can underplant new species under canopy. Under canopy, we can apply group selection, and we can also apply irregular shelter wood systems. I will focus a bit more on this silvicultural system because at least here in Southwest Europe, hasn't been applied much. Again, it's not a new method. It is already explained in this book in 1928, so 100 years ago, near 100 years ago, it is already explained here. It has two variants in that time. Basically, it consists of opening gaps, and the idea is that shade-tolerant species can grow in these small gaps. It's basically something in between group selection and shelter wood method, but it's not actually the same. Okay. More recently, this kind of method has been paid attention in Canada, and this publication, now in the 21st century, it summarizes very well the method. If you want to know more about the method, I recommend to read this paper. And they define three different alternatives to this irregular shelter wood system: the expanding gap, the continuous cover, maybe you are more familiar with that, and the extended gap, for example. So the extending method, sorry. The expanding gap is the one that we will try to apply here. Basically, it consists of opening gaps, and then in every intervention, we are expanding such gap. So we are not opening new gaps in the stand, we are expanding the gap. So that's the main difference, for example, with the group selection method. Okay, so key decisions to apply this method is the gap size, of course. If you know something about gap silviculture, It depends on the dominant height and the diameter of the gap. Usually, in a standard application of group selection is 1.5 to 2 times the dominant height of the stand. The number of gaps also in the stand, usually it is calculated on an area basis. So a normal value is around 20% of the area is open. Another decision is if we are going to plant within the gaps or between the gaps, if we are to plant new species, for example, because we want to accelerate the process of mixing. And also another way is if we are going to reserve some trees within the gaps or not, okay? Another decision could be if we are going to thin the matrix between the gaps, for example, or just to leave the matrix without thinning between the gaps. Okay, so this is a view of one of the gaps, of course. So I'm going to explain you a couple of applications of this irregular shelter wool system in Mediterranean forest, which is the basis for the COMFOR network. So far, we have already 3 sites, the 3 of them in Spain. There must be another one in Portugal, but tomorrow we will discuss if it is possible to install that experimental site in Portugal. But just they are located more or less here. This is Sierra Norte, I will show you later. This is Cabañeros, and this is La Siberia. But we're going to tell you only about the 2 first of them. So, Cabañeros sites is a monospecific stand, monospecific plantation of Pinus pinaster around 50 years ago. Here, Pinus pinaster is a very light demanding species, so we open large gaps. Probably the gaps will be filled with Pinus pinaster, and this is not the objective in this case, because the objective for this site is to transform the pine wood, the reforestation, into a mixed stand. So we applied very small gaps. As you can see here, only half of the dominant height, which means 8 meters of diameter of the gap, 1 time the dominant height of the stand, which means here 16 meters of diameter. So they are quite small. And here in this case, we call it very small and small gaps because they are smaller than the usual way of applying the method. We also applied a thinning in the matrix around the gap. Okay. So in the gaps here, we decided to plant Quercus species because we wanted to accelerate the establishment of this species, although there are some saplings of Quercus also that were present in the underneath the canopy. We have a control with no intervention, which is this part of the experimental area. What we are doing is to follow up regeneration and the plantation performance in terms of survival and growth of the plantation. Okay, so you have the idea is that now we will transform this stand in another 50 years because we are going to expand the gap every 10 years, more or less. So this means around 5 interventions, 5 harvesting operations. So hopefully, if I have another 25 years of working life, probably I will see half of the transformation. But you know, this is a long-term story, this research of us about forest. Okay, I'm not going to show you results because this site we already have 2.5 years of following up of the regeneration. I would like to invite you next autumn to Czech Republic. There will be a meeting, a UFRO meeting about uneven age and mixed stands, and I will show you information later about this event. Okay, so this is this sketch of this experimental site. Sorry, it's in Spanish. So we have all combinations of the 3 species. Okay, we have 3 replications of each combination, and in some of them we also close the part of the gap to avoid browsing because it's very important in this area. And also we have some gaps without planting, just to follow up natural regeneration. Okay, so this is the way, this is the forward working in the gap. You can imagine the gap here, how it's been, has been opened. The other side is more tricky because it's in a very steep slope area with terraces. This is the usual way many reforestations were performed between the 50s and the 70s here. And it's very challenging here to open gaps because it's so steep that the machinery cannot go downhill, so they must go through the terrace. So this is an example. So that's why we call these rectangular gaps. It's not, they are not circular anymore. We try to keep also the same size, 0.5 and 1, but it depends on the width of the terrace. So we open 3 terraces here and 2 terraces here. So the size is 20 meters long, and here is around 7. I'm sorry, it's missing here the value. And here it's around 14, 15 meters. So this is the size of this rectangular gap. Here, where we planted is European beech, birch, some service trees, and also oak. And we have also a control, and we follow the regeneration performance. In this case, we don't have all the combinations because of limitation of space. So what we have is the pure plots, the 2-species plot, and also, let's say, higher diversity plots. It's missing here also with birch, okay? So with the beech and the oak and so on. Okay. Yeah, we have also 2 replications of each sides in this block. Here we also took into account the slope, so we have 3 blocks in this case because there are high differences between the upper part of the slope and the low part. Here I have this aerial photograph. This is the area previous to the intervention. You can imagine here these rectangular gaps. Okay, pay attention to this area. This is a heather gap, natural gap filled with heather, no trees, okay? Just for the next photo. And this is before the harvest and after the harvest, and this is this natural heather gap with no trees. So this is basically our experimental area here. So this is a brief introduction of both sides, results on the performance of the plantation and the regeneration will be presented elsewhere. So we would like to create a network with these experimental sites because they are quite specific for transformation method, which is a valid option for mitigation or adaptation of a species. So if you want to join the network, there are just these few requirements, which is that the main objective must be increased complexity, species, structure, or both. It must include a control area. The control can be a business as usual or can be just doing nothing. It must include replications of the transformation of the control, of course, and of course must include the participation of stakeholders and forest managers because they decided the species and they decided the combination also that they want to test. Okay, so thank you very much. This is a photo of both species together in oak and pine in the Cabañeros. And it's, yeah, thank you very much. So you have any question? No, I just okay. Yes, because we are really ahead of time. Yes, thank you very much. So we can move to the. Of course, if you want to join the network, you can contact me for any other question. Yeah, no te enrolles. SMB, la última. 81. Mucha foto.
Sí. Hello, everyone. So my name is Susana Barreiro. I come from School of Agriculture in Lisbon, and we were one of the partners of the project. Andres included in the agenda the title of my presentation as Experimental Sites in Complex Forests in Portugal. I don't think this meets exactly the content of my presentation, so I changed it to Summary of the Portuguese COMFOR sites. I hope you don't mind. I will give you a little bit of background. Fong, in her presentation, already talked a little bit about the Portuguese forests and the mixtures, but I'll complement it a little bit. Then I will tell you what was originally planned when we applied to the funding and what we achieved to do in the project, and I'll talk a little bit about the sites. Fred already talked about the Martelo scope. We set some permanent thinning plots within the project scope, and we have also the triplets that Alexandra Correia might be talking a little bit in the afternoon, and the mixed plantation that Benoit already mentioned as well. So about the background, some numbers about the Portuguese forests. Most of our forests are traditionally planted. You can see in the graph, maybe the numbers are too small, but we have information dating back to 1874, and as you can see, we barely had forests. Then there was a huge investment in planting evergreen oaks, shown in yellow, and over the years we started planting maritime pine, the dark green tree species. Around the 60s, 70s, we started planting eucalyptus, the light green tree species. We have stone pine rising in the 90s and the area increasing up to the last National Forest Inventory dating to 2015. And then we have other tree species in orange. So as you can see, we don't have a lot of diversity in terms of tree species. We have around 36% forest cover in Portugal. Most of it was pure even aged, except for cork oak plantations south of the Tagus River. Fong also mentioned that we have a very high percentage of private forests in Portugal. She mentioned a higher value, but I think they are around 97% of forests privately owned. And as you can imagine, these bring some constraints in terms of management. The main tree species are, according to the graph, obviously, eucalypt, maritime pine, and cork oak. And what you don't know, or you can guess, is that most of our forest area, especially above north to the Tagus River, is very small, fragmented, and with scattered plots. The same forest owner might own very small areas scattered in different regions. So this brings a lot of constraints in terms of management. The main threats. Population is aging. We are under rural abandonment for a long time. We have recurrent wildfires. You can see the graph. We have information. Oh, Jesus, the numbers here are even smaller, but I can tell you how far back we have information on burnt areas in Portugal. And the last bar, the last bar, this bar here represents 2022. So you can imagine every time we have these massive wildfires, such as the ones we had in 2005 and 2003 and 2005, and here 2017, what happens to our forests? Another big constraint is that forestry is not profitable in Portugal. So having 97% of the forests being privately owned, you can see how much the forest owner is willing to invest in managing his forest with such wildfire recurrence and having no profit coming out of their forests. And then we have an additional problem that I call UFOs. You might be wondering what this means. It means unidentified forest owners. To make matters worse, in a lot of the areas in northern Portugal, we don't even know who owns the land. So it makes everything even more complicated. One additional threat to forest management, which I'm not mentioning here in the slide, but it is a reality, is bureaucracy. Every time a forest owner decides to make a plantation, the process, the submission of an application to plant is quite bureaucratic. It takes a long time, so it's quite complicated. Some trends I used, unlike what Fong presented you, she used the data that we requested from the National Forest Services. We don't have our data publicly available, so we had to make a request under the scope of the project to use the data at tree level. We just had access to what was published, and the graph that I'm showing here in this slide is based on information that had been published. So we know about the area of pure and mixed species, but we don't know the secondary species in the mixture. So this is just focusing on the pure and the dominant tree species in the mixtures, but we don't know with each species each of these are mixing. And if you look at the slide, what you can see is that there is a trend, an increasing trend in the mixtures. If you compare the data from 1995 up to 2015, for some particular tree species at least. Regarding the decrease in pure stands of maritime pine, I think, but this is my guess, this is due to natural regeneration being promoted over plantations, given the extremely high costs of forest management for our forest owners and the fact that we have so many fires in short periods of time, repeated fires in short periods of time. Forest owners associations are recommending private owners, and they understand by themselves that they don't have a lot of money to invest. The biggest amount of investment is associated with preparing the site and planting. So a lot of them are choosing to wait for natural regeneration of pine instead of planting. The mixtures of maritime pine and eucalyptus, they are not planned at all. In my personal opinion, they result of this lack of management that results of forest fires occurring so often. Then we have an increase of cork oak and stone pine, which in my understanding is the planned mixture that we have in Portugal. So the areas increase of these two species because the owners plan to plant them mixed, and I will tell you later why this is happening. And for stone pine, because the owners felt that they could get some income from cone production, so the areas have been increasing over the years. I don't know, I do not have an explanation. Maybe the increase of the other broadleaves, all the other broadleaves that we have in the country, which represent very small areas, result also from lack of management, and they are naturally regenerating after fires. I don't know for sure. These are just some expert guesses. I don't know if they are smart guesses or not. Other Portuguese in the room may discuss it with you. So adding to this information, I can also show you the status based on the National Forest Inventory dating to 2015 of pure and mixed stands versus the even age and uneven age. So you can see that, again, we have a high area of uneven age stands for maritime pine, even the pure ones. And again, I think this is a result of natural regeneration being promoted over plantations. We have a higher percentage of uneven age stands, both in pure as in mixed stands of cork oak and olm oak forests, because these species have been always traditionally managed as uneven aged, or mostly managed as uneven-aged. And now I will tell you a little bit about what was planned and what we were able to achieve in the project. So by the time we submitted the application to the funding, we had originally planned 2 study areas, one in central Portugal, Lausanne, and another further south, closer to Lisbon, Coruche. In the central Portugal one, we were supposed to have established the martelloscope, the transformation site, and carried out all the studies regarding forest typology, hazards, environmental services, and fire risk assessment. In Coruche, the idea was studying the mixtures of cork oak and stone pine, having the triplets, and eventually the mixed plantations. Since we knew that a lot of forest owners were planting the cork oak and stone pine, combined, we thought that the mixed plantation could be carried out for these species, focusing these species in particular. So this was the original idea. Well, things didn't go how we planned. The project only had a short number of months for forestry research. We were confined due to COVID for most of the for the first year of project, and then we could start coming out and circulating in Portugal, but not that much. And we had severe forest fires that compromised the Lausanne study area, and alternatively, we had to find other locations for studying what we had planned to study in Lausanne. And due to confinement measures, due to COVID, we had a hard time getting people to reply emails and going out, being able to carry out field work. So this was quite challenging. We had this window to find alternatives to Lausanne. And then after we started making new contacts and starting to find the new place to settle, the mixed plantation, the martelloscope and everything, we got another restriction, which is represented in the box, the fire restrictions due to severe forest fire hazards that prevented people to do any kind of action in forests and circulating in forests. So everything was compromised again during the summer, and we only had this small little window to carry out all the work that had been planned for the whole project. So I kind of think Andres was saying that the transformation site was compromised. I think that we accomplished quite a lot in such a short period that we actually had to work. So the alternative for the Lausanne site was shifting part of the studies related to forest typology, provision of environmental services and risk mitigation that Leonia presented this morning to this other region further north in the country and using existing data because we had no possibility to collect data. The Penamacor site, this was the supposed transformation site where we had a maritime pine, 40 years of age stand that had never been thinned and belonged to one of our pulp and paper companies. They were willing to do something in it because they had never done anything to the site. So the idea of opening some gaps pleased them, and they were open to cooperate with us, but with all the fire restrictions, and because the area is located really close to one of a protected area, they have a very small window of intervention in the forest, which coincided with the fire hazard peak, and we had to suspend the work. The project is about to end, so I don't know exactly. Andres said that we should discuss this tomorrow, so we will see. Then we shifted the martelloscope that Frederico presented this morning to Orem, and in Coruche and Canha, which is somehow close to Santarém, like Benoit presented in his mixed plantation summary, we were able to establish a mixed plantation of eucalyptus, strawberry tree, and cypress, where we have the pure plots, the combinations 2x2 species, and one plot combining the 3 species. In this region here, we also established permanent thinning plots of cork oak and stone pine, and we have some triplets scattered in the central part of Portugal. So a little bit about the sites. Remember what I told you, we have 97% of privately owned forests. If we don't get the owners to cooperate with us, we don't do anything. So it was really difficult to find a place where to establish the martelloscope, and we were approached at ISA by the owners of an old farm that used to have agriculture and forestry use, but over the years they stopped using it for agriculture. They didn't do a lot of forest management, but the trees started growing in the areas where they used to have the vineyards and the olive groves. So now at present, the area is basically dominated by forests, not so well managed, and they needed our help to prepare a forest management plan. You can see in the map the distribution of the different strata, you can see that we have very, very small and thin strata, so squeezing the martelloscope in here was a challenge. You will see how we did it. And the owners of the farm, this belongs to an old colleague of mine. She inherited the farm from her family, and she now only dedicates her life to it. She recovered part of the buildings, and she has a rural tourism that to provide her some additional funding, and she's very interested in cooperating with us. So that's the reason why we chose this area, because we know that we don't run the risk, or so we hope, of having the martelloscope harvested or something in a couple of years. So where was it located in the whole area? Do you see the rectangle in the bottom? So that's where we were able to establish the martelloscope. Instead of having a 4x4 square, we have 8x2. We had to distribute it in the only area that was available. And this required some activities. Since this area was not the planned area for the study, when we applied to the funding, we did not include shrub cleaning in the application. So this was a major stress, because we were not allowed to do shrub cleaning and pay it with money from the project. We had to request permissions, which delayed all the work. This was how the martelloscope looked like before the intervention. The idea was to fly with airborne and terrestrial LiDAR. And if we had the stand looking like this, everything would be compromised, because we wouldn't be able to get any information out of this. Frederico wouldn't have been able to circulate inside the martelloscope, so we really had to clean it. It took us quite some time to get the permission to do it, and that's why we are still dealing with the traditional field measurements. So this was the work of the field crew that went there to clean the shrubs, and this is how it looks now. I heard that the shrubs are coming back strong. Remember that Fred mentioned that he had some troubles in matching the data, the cloud points collected in the field with his terrestrial LiDAR, with the cloud points obtained from the flight. So the idea was creating these 3D reference balls. It took me quite some time to prepare them, and then we went there before the flights. And Frederico came to scan it. We went to the field and we scattered some of these, all of the balls in the martelloscope area to serve as reference for them to be able to merge the two data cloud sets. You can see some pictures here. The result is this one. You've seen the pictures before because Frederico has shown it. And the results that we've been able to obtain so far are these, the traditional field inventory. I had to prepare a field protocol and discuss it with the team that is collecting the data in the field. Frederico had a lot of concerns because he doesn't trust the measurements of tree heights that he gets from field. So I had to sit down and analyze. I visited the site, I took pictures, I sat down with the guys that are doing the measurements, trying to tell them what kind of information should be collected and trying to imagine how you see the bottom pictures, we have these trees. I call them bouquets because they kind of look like a bouquet. We don't know. Some of them we think there are ash, they don't have any leaves, so they are difficult to identify. The martelloscope is quite complex. In the beginning, the strata where we settled the martelloscope was classified as cork oak, not specified which oak it was, and eucalyptus. And in the end, we have a very wide combination of species. We have hash, we have oaks, we have cork oak, we have, oh sorry, I think I pushed some button. We have oak, we have stone pine, maritime pine, so it's quite complex. The field protocol also includes, apart from collecting data on trees, they also have to collect information on microhabitats and deadwood, so it's taking them quite a long time. In the meantime, they've sent us some field forms with data that correspond to half of the martelloscope data, and we have already started processing this and working on the R scripts to be able to give Frederico as soon as possible some data for him to validate the cloud points. In the future, we would like to develop an app to be able to allow our students to visit the site. I didn't mention, but we bring our students to this place because they have lodging. So the Forest Inventory Field Week is spent there every year, where they do measurements in different strata of the farm. And the idea is to use the martelloscope there. It's located in central Portugal. They can host people coming from other universities. So the idea is to potentialize the use of the martelloscope by different institutions and universities being located in central Portugal. And we want to develop an app to allow people to use it in the field. The permanent thinning plots are located close to Coruche. This is the look of one of these plots. So the owner had huge troubles in recovering one of his cork oak areas. The trees kept dying while he insisted to plant it as pure. And after the third try, I think, he gave up and he started a plantation of mixed cork oak and stone pine. He did it because he had very low survival rates and he expected to have some additional income from the stone pine that he grafted to anticipate production. So he had a problem and he contacted us because he didn't know exactly what density. He had to plant it with a very high density. You can see you have a lot of pine trees and a few cork oaks. We have regeneration of cork oak here that you cannot see. And he had already performed one thinning, but he was not certain when to take more pine trees to reduce the density and competition, and he didn't know exactly the amount of pines to remove. So we settled 3 plots there. We measured all the trees, we marked the trees, measured for height, diameter, and crown radius. We have them marked, we took coordinates of all the trees. There's an example of a plot there. This is a picture that shows that the 2 species like growing together. You have an example of adult trees that have, the adult ones, they have not been planted. They just grew together. They regenerated and grew together. And what we can observe is that close to each stump of an harvested pine, we have, you maybe not see it very well, but you have regeneration of cork oak next to each of the stumps of the pine that are removed. So now the idea was we followed the thinning. He had a crew to thin the area. And in the 3 plots, we have no pine trees removed. In the other plot, 5 pine trees were removed. And in the 3rd plot, 40 pine trees were removed. So the idea now is to follow the plots and revisit them. In the future, in the near future, we are going to go back because we don't have a lot of information on grafted stone pine. We don't know exactly how it grows. The model we have developed is mostly based on non-grafted or ungrafted adult trees. We don't have a lot of information, so the idea will be to measure the growth between the knots of the last years to be able to have together some information on height growth for these young pine trees. A little bit about the triplets. I'm just about to hand. A little bit about the triplets. The location is all along the area where we find the mixture. Shanna has a lot of triplets. I'm just giving an example of 2 of them. We found areas where we could establish the mixture and both the pure, find both the pure species. So we have a lot. Shanna will talk about that later in the afternoon. So we have a huge amount of triplets that are now being established. We don't have 14 years of information because we are just now establishing the triplets, but in the future we hope to be able to contribute to whatever studies you do on triplets. The final thing is the mixed plantation. It was established in the existing property from Altri Florestal, a pulp and paper company. The green area in the map represents eucalyptus and the orange or yellowish cork oak. They were They harvested one of the areas of eucalyptus and they set aside 3 hectares where they were willing to do some mixed plantation. We visited them, we discussed with Hervé and with the responsible for the research in Altri, where the combination of species, where the blocks would be, and this is the result. So we are combining Mediterranean cypress with eucalyptus, globulus, and strawberry tree. And as you can see, we are not just focusing on wood. We have a fruit production. Eucalyptus is used for pulp production, so it's not exactly wood for noble purposes. It's to be transformed to pulp. And then we will see how cypress will do. You have some pictures, and the 3 pictures on the right-hand side show you the plantation. We had some troubles with strawberry tree because we had heavy rains in November, and some of them had to be replaced, but things are going. Thank you very much. Questions? We don't have time.
No, we don't have time. No, I mean, sorry, Susana, thank you very much. We really behind the time, so we will move the last presentations for this block after the meal. We will have less time to have lunch, but still we will have time to have lunch. So thank you very much. Now I will show you where we are going to do the lunch, and see you in 1 hour. So we need to reduce the time for lunch. Okay, thank you.
Good afternoon. As promised, now I'm going to introduce briefly UFRO, who is co-sponsoring this symposium. UFRO stands for International Union of Forest Research Organizations. It's a global non-profit and non-governmental and non-discriminatory scientific organization. You see here some figures. It's open to all individuals and organizations dedicated to research related to forests and forest products. It has a long history, as you can see here, in the end of the 19th century, so more than 100 years, and is based in Vienna, in Austria. The vision and mission of UFRO is to be the global voice of forest science to promote a sustainable future for forests and society. And UFRO tried to advance research excellence and to reach research excellence and knowledge sharing, and fosters development of science-based solutions, always in relation to forest challenges. The structure of UFRO starts from thematic areas, for example, for people, climate change, forest-based products, biodiversity, ecosystem services and biological invasions, and also interactions between forest, soils, and water. So I know that many of you know how UFRO works. Just this could be a reminder. Members are research institutions and organizations, but also individual scientists. Provides a diverse thematic structure, and within this structure, scientists collaborate on a voluntary basis. Well, this is the structure of UFRO. We have this international council, board, headquarters, and the executive body, let's say that, which is the divisions, the task forces, and special projects and programs. So UFRO has 9 divisions. Here they are listed here. As I told you, I'm the coordinator of a research group, the O.09, Silviculture and Dynamics of Mixed Forests, which belongs to Division 1, Silviculture. But you have, those topics also cover. A task force is a temporary, let's say, research agreement during each 5 years UFRO Board to advance interdisciplinary cooperation, and more importantly, in emerging key issues. So it's in the very front line of forest research. These are the current task forces: forest education, monitoring global tree mortality, which is really especially important these days due to global change, forest-water interactions, gender equality. So you can see here that we do not only deal with forest ecosystems, but also with all the social aspect of forest ecosystem from a socio-ecological perspective. The program and projects provide services that support the science collaboration in UFRO. For example, we have this SPDC, a special program for development of capacities, capacity building, a special program director for also to exchange of knowledge and on the advancement of the management of forest research. Here you can have 2 others programs like the World Forest, Society and Environment. As I told you, society is in the very center also of UFRO activities, and a terminology project just to unify or harmonize forest terminology. We have also this Global Forest Expert Panels program, and that with publications, you can see here a list, and to be published soon, the Forest and Human Health. And if I'm right, I think it's already published. It's already published, so you can also download this Forest and Human Health, which is also really important. We all know how important are forests for controlling pandemics. You can have more information in these media and publications, on the website for sure, with social media, newsletters, World Series, and other communication channels. If you are not a member, I would strongly recommend you to be a member, because it's a good opportunity to share your work, your experience, and also to connect with other scientists and with other people working on forests. If you want to be involved, for sure, visit the webpage, and you can find here more information how to participate or co-sponsor events like this one, for example. This is the direction, the contact points, and see you at the next UFRO meeting. And here I would like just to reach your attention with this conference, which is a joint conference between the UFRO 1.05 and 1.09 research group. 1.05 is uneven age silviculture. Along with us, with the mixed forest research group, we organized this conference, Uneven Age Silviculture, Insights into Forest Adaptation in Times of Global Change. Will be in Czech Republic, in Prague. And you have here some important dates. You still have time to submit your abstract submission, and all the information it's here, and I'll be there also. You can see here with a keynote speaker with other colleagues in Prague. So thank you very much for your attention, for your time, and I hope if you didn't know UFRO before, I hope now you have the anxiety to join the network. Thank you very much. And now we go on. So you remember we have one presentation, which is in PDF, Cristóbal? No. Okay, here it is. Cristóbal, yes, the floor is yours. I beg you.
I will be brief. Very brief. Thank you. Hello, good evening. I am Cristóbal Ordóñez. I'm working at the University of Valladolid in the U4. And I will present a Smartello app, which is part of, is one of the product of COMFOR-SUDOE. And we don't have the final version, but we can, with this code, we can download the version, the current version we have. Before start, I want to thank Susana and Pion for the work they are done with with almost no help from our part, from outside, but I think that. Oh, okay. Yes. Thank you. I think that we can finish the analysis, and we can use in a good way this app. First of all, this Smartello app want to take advantage of martelloscope, of every martelloscope. So what we want is to have the data of the martelloscope. Everyone can upload or can use their own data. Not sure in the current version, but it will be for sure in the in the final version. And well, a martelloscope, as probably everyone knows, is a part of the forest in which we know everything about well, here you can see what I have. This is a map of a martelloscope. So what we want is to have every tree map in the martelloscope, just to be able to go to the forest with the map and mark the trees to be cut or eventually to be preserved as very good trees or whatever, with whatever purpose. So what we want is to use the forest, the plot, as a tool to teach people how to perform thinnings. Or the martelloscope, it's a work very, very tough to get the data. So we want to use in many other research purposes. So going to the app, what we need is an inventory with 2 tables. With this, if you scan this this code, this QR code, you can download a template of the app. The template in the form we need to be used. It's very important the position of the columns, because otherwise the app doesn't work. So we have this template with the data at plot level. We have reserved the 0 ID plot for the whole martelloscope, and we have 16 quadrants in which we divide this martelloscope. But if you have only 4 quadrants or the number of subplots you have, you can change it. It's up to you. You can decide how to separate your data. And the data have a plot level and tree level. And this is only a part of the template. But if you want, you can download. Once we have this data, this Excel or whatever format, we can use Excel data to use directly with the app. I don't know if this. We can upload in Excel format or in CSV format, but what is more comfortable is to use Seman4 to access to the data. So what we use, what we do is to log in with Seman4, the third option. We can use these 3 options, but the more comfortable is previously upload to Seman4 the data, the template with your own data, and then login. After logging, we select the inventory. This is all the inventories you can access with the format of Smartello. Seman4 have 2 kinds of data, Smartello app data or Seman4 normal data, which is for for run scenarios of growth and apply silviculture. Once we select the inventory, we can select all plots, or if we want only work with one of the subplots, we can choose only one. We can both the complete martelloscope or only one of the plots. Once we are logging and and we have the data load in the app, we have three different screens in the app. The one with the information of the trees, a map, and a graph which is more or less the same, but actually we decide to have these two different options, but what is more useful is to have the map, because in the field we can use this button to use the GPS of your phone and go to the trees with the precision you have with the mobile phone, but you will be close to your to your plot. Okay. We can make filter. We have this button to filter and select small or big trees or tall, or we can also make selection, see only the trees we have an action plan to do after doing the data. In the once we have one tree selected in this part, we can perform an action with this app. The action can be plan to cut the tree, and we have up to 10 options, 10 causes, because we want to cut the tree. Or we have the option to preserve the tree. We have, if we have a list of options to preserve, and we can increase this list. And if we push the button of actions, we have the information of the trees selected. And we have a mark that means we want to cut. This is a saw. I don't know if it's possible to see easily. Or we have a leaf if we want to preserve this tree for the future. Once we work with the plot, with the trees we select, we have the option, which is the most interesting part, is to export the data, the information of the trees we have selected to cut or to preserve, and we can export as a list with the button share. We can save on the device and use in the future, or we can send to COMFOR. Finally, the best option is send to COMFOR, because in COMFOR we need to get an account, a free account, of course, and we need to log in to the platform. But this platform allows us to, with the data we have from the app, we can generate a file in which have an Excel file with lot of different information, with all the information we enter to the tree, with the information of price, ecology, the different people who work with this data. We can have different analyses with this, and many graphs. This file is generated with this option of COMFOR. And as I promised, it has been very quickly. It's a rough, a brief information of the app. What we want is to make them more usable for all of you. This is a free app, and I think that it will be very, very good if we can use for all the telescopes. That's all. I don't know if
there's any questions for him.
Hello, thank you for your presentation, because right now I'm more understanding about the app. I actually have 2 questions, but I only ask one because of the time limit. So you mentioned that right now the map and the graph is similar. So
yeah, it is almost equal information.
Yeah. So when the app is completed, what is the function of the graph? Or you will
Actually, there are no differences. So what we plan is to have a graph, but I think that in the future we can have graph of the, I don't know, the different options with diameter distribution or height distribution, this kind of graph, not the plot, because we have the plot in the map, so it makes no sense to have both. Yeah, you're right.
Yeah. Okay, thank you so much.
Cristobal, thank you for the presentation. I have a question, it's not related to what she asked. When you say that we can choose either to harvest a tree or to thin one tree, to select the tree to be thinned or to preserve the tree, I don't understand exactly the meaning of this. Is it these trees are marked as preferential trees to be thinned when you run the simulation and you do the thinnings that are prescribed in your inputs to run the simulations over time? Is that it?
Now, there are no relationship between what we mark and the run simulation. This is an idea for the future. Okay. Now, what we have with this version of Smartello app is an Excel file with lot of graphs and lot of analysis.
Yeah, but you don't assume changes based on the selections that you make of trees?
Yeah.
Do you reflect those trees selected in the graphs that you show?
Yeah. Okay. That's what we have.
That's what I wanted to understand. I wanted to understand if we had to run COMFOR to see the implications of the choices we've made or not.
To have this output, the information of the trees we have selected, is necessary to run COMFOR, because otherwise, I understand the background of your question. Perhaps it makes no sense to upload the data and run a simulator to have these graphs. But it was very complicated to do this on mobile phone.
Yeah.
So that's what we thought. We already have this Excel file, and what we did was to run in COMFOR a program to make the input to this file, to this Excel file, and run everything inside COMFOR.
Okay, I'll talk to you later.
Thank you. Any other questions? Well, then now we're going to have David Alvarez from ECOAXA with the evaluation of complex forest. And you say everything.
Hi, how you doing? I'm going to try to make this presentation as amazing as possible, considering that we are after lunch and maybe some of you will prefer to sleep instead of being sit here. Okay, let's see what I'm going to speak this afternoon. It's about what we have done with natural capital in this project during the last 2 years. During this morning, we've been speaking a lot about what does ecosystem services means and what's the importance of ecosystem services in complex forests. And what we tried to do during those years is to capture and somehow the value of these ecosystem services through different valuation techniques and accounting methods. And that's what I'm going to explain during the next minutes. What I'm going to show you this afternoon is, first of all, what's our idea of what's the natural capital approach and what does it mean and what did we took this approach to integrate during this project. Secondly, how did we make this the application of the natural capital approach for complex forests and the different deliverables and products that we got from the application of this project. And finally, once that we know what's the final application of and how to apply the natural capital approach, what are the different opportunities that could rely on these and the different opportunities that could be applied not only for complex forests but also to other opportunities in the market. So first of all, have any of you know what's the natural capital approach? Or what does it mean and what comes to your mind when you hear this natural capital approach? Any of you? I have to explain from the beginning? Okay, let's say, when we speak about what does the natural capital approach, it's a way of thinking about nature, about an asset, a natural asset that provides benefits to the people, to the society as a whole. It's what we're speaking this morning when we speak about the concept of ecosystem services. Ecosystem services, it's just a benefit that natural capital assets provide to the society. If there is any functioning of nature that does not provide any benefit, it's let's say it's a way of how nature functions, but it's not an ecosystem services. So that way of thinking about nature provides tools and alternatives to assess what's the value that nature provides to the society and nature provides to the economy.
in fact, by following this methodology, we can not only see which are the benefits that nature provides to the society, but also we can also assess what's their impact and dependencies on economy that different natural systems have to the economy and to the society, and to measure which are the impact and dependencies of, for instance, different businesses or companies across the world. If you are familiar with biodiversity regulation, for instance, at the end of last year was released the new Convention on Biological Diversity, the new Biodiversity Global Framework, which is very much focused on one of these topics and how to, and there is a new obligation mandatory obligation for large companies and financial institutions to disclose their impacts and dependencies on nature. And this is one of the main uses that could be applied in the future. So to do this approach, it's not something that we have invited. We have followed the system of environmental economic accounts, which has been developed by United Nations for the last 10 years at least, where it's been developed an accounting system to account all the information regarding nature and following the approach that I've explained previously. I mean, we have assets in nature, and when I mean assets, I refer to different habitats, different species, and the different components of nature. And the combination of all these assets provides flows to the economy. It's what it's called benefits or ecosystem services. And you can see at both sides of the screen. But to provide extra information, we are not only speaking about assets and speaking about flows only on biophysical information, but also providing economic information on what's important of both these assets and these ecosystem services and flows. I'm not going into detail in this. It's just to give you a brief idea on what the approach means and how it's and what I'm going to tell you is how did we make this approach during this project. So as I mentioned, we have done different works during these 2 years and a half, almost 2 years and a half, to make the application of the natural capital approach to complex forests. This is one work that has been done for the University of Valladolid in order to capture the meaning of place and the social perception of forests. I'm not going to explain anything about this because they're going to explain further, much more in detail, so I won't stop here. So what we did, it's first of all to make a holistic review on what was the information regarding the different valuation techniques across the world for complex forest and how could they be applied to the SUDOE region and this context. And based on that, we made a report for managers and policymakers for the different methods for monetary and non-monetary evaluation for these ecosystem services. This work was presented in the Spanish Forestry Congress, which took place last year. And based on this research work, we also did a decision tree to make it easier the selection of the different methodologies in case that you need to decide which methodology do you need to make the evaluation of the different ecosystem services that you can find or you might find in a complex forest. So once we did this initial assessment, we have the different evaluation techniques. We need to put all these techniques into a methodology that could be applied to the different pilots that we run during the projects. So as I mentioned, I'm not going into detail of the methodology. We will need a lot of time to do so. Just to have a brief update on what we did. Based on these different valuation techniques, we define a methodology. First of all, we did an initial materiality assessment on which was the most relevant ecosystem services that you might find in complex forests in the SUDOE region, and that was a work done by all the partners of the COMFOR-SUDOE, where we selected the most relevant ecosystem services, and based on that we built the methodology based on the SIA framework that I've shown you at the beginning of this presentation. Once we had this methodology, we're preparing a final guidance for the application that will be uploaded in the upcoming weeks before the project finishes. And we have run this methodology into pilot projects here in Spain, one in the Monte de Valdepozas in the region of Castilla y León, in Palencia, and the other one in the region of Extremadura in the Dehesa Boyal de Jarandilla de la Vera. In both places, I guess, there was also developed a martelloscope assessment, so part of the information that they have taken from the martelloscope could be used for the evaluation of these, for the evaluation and accounting of these forests. I'm not going to show you any data of the final results, but what you could find in the end, it's an Excel sheet where you might find the results of the different assets that take part of every forest, measured in extent and condition. I mean, what's the total surface that they occupy and the condition of each habitat or each species or whatever it's in its forest, and the value of the different ecosystem services provided by each different asset. What you can see in the screen is the tool that we have built during this project. This is our website tool that it's going to be available at the end of the project to, in an easy way, and that was one of the goals of this project, has a tool that make easier the accountancy of all these ecosystem services in order to see what next steps could be done in the future, and that's what I'm going to explain later on, and apply this accountability tool for different managers, thinking in a very practical point of view. This is a summary of the different products that we've been developing during these 2.5 years. I'm not going to go in detail, but that it's just to show you how was the process of the different activities that I've been explaining during this presentation. Finally, what are the opportunities that may arise from this work? And that's the title of this presentation. I'm not going to focus on the details as I mentioned. I would like to focus on which are the different opportunities, thinking and how could this approach be used in the future. The picture that you can see, or the graph that you can see in the screen is a graph developed by the DEFRA. DEFRA is the environmental minister of the United Kingdom, which they've been working a lot in ecosystem services and natural capital accounting for a long time, almost 10 or 15 years, even before or at the same time that the SIA from the United Nations was developed. But considering not only in a technical point of view, but also in practical tools, and they have included these practical tools in different regulations in UK. So, as I mentioned in the beginning, when we speak about the natural capital approach, we're speaking about assets, and that's what we have in the upside of the screen. And we have these assets, and we have the different ecosystem services that may arise from the different assets. Based on that, we need a system to capture all the value and measure which are the different assets and make the different valuation, use the different valuation techniques, not only to make the biophysical valuation, but also to make the monetary valuation. And based on that, we have a bundle of information that might be used. How can we use all this information? What's the purpose of the information that might be account into this system? Speaking in a broad sense, or speaking in a let's say in a policy from a policy point of view, you can see in the green row the different point of view or the different uses that could be used in the for the natural capital approach. You might have an asset and risk register. I mean, how is an asset being modified during and across the time? Of course, we don't have the 80 to 85 years that the professor Mark mentioned this morning, but based on that, we might or we are able to build a series on how assets evolve during the time, and that's very crucial, and that provides a lot of information for different purposes. One of the purpose that we can use this information is for environmental impact assessment, either for projects or for planification for global projects, and that's something that it's been very useful, for instance, and has been used for a long time here in UK, and it's starting to be used in other countries across the world. Also to make sustainability appraisals to compare the different alternatives for programs or for projects at a policy level. Of course, you can have the physical and economic accounts for social or economic purposes. Last week, I participated in internal meeting in Catalonia to start thinking about how to use this approach, and the statistical office provided us a lot of different uses that could be done based in this information. And finally, speaking about policy development, what could be the regulatory impact of the different legal frameworks that might be in place. This is speaking broadly, as I mentioned, and based on only from a public point of view. But if we speak on what could be done from the point of view of a micro level or a company level, this system allows us to make a cost-benefit analysis to assess the different alternatives. For instance, in a project, you have mentioned, or in the previous presentation was mentioned what was the different alternatives or the consequence of the different alternatives using the Martella scope, and based on that, put it in CIMA Pro. With that, if we could include also economic valuation for the consequences of these activities by measuring the different ecosystem services provided by the different assets, we could also have different information to take decisions. This is the most important issue for the natural capital approach. Have a tool for decision making. Build business models. We've been speaking not about assets and how to manage those assets. We are also speaking about the different ecosystem services that may arise based on these assets. One of the ecosystem services is how do we capture carbon, or how do we regulate the climate, or how do we regulate hydrological watersheds and all of them. Or many other ecosystem services. Some of them are starting to have price in the market, but all others might have price in the near future. For instance, biodiversity through biodiversity credits or watershed credits through watershed credit management areas. This is a way to capture the value of these different ecosystem services in order to provide extra value for the forest managers and provide extra incomes to the forest managers. For instance, in places like Spain, Portugal, or the south of France, where this kind of where forests used not to be very profitable only by selling the wood that it's provided by the forest. As well, this system could be also used for funding mechanism through different payment for ecosystem services or other systems like this, the information base that you can store during this store an account through this system. And finally, and link to the topic that I mentioned at the beginning about the new regulation on biodiversity at a global level, to start assessing the risk. Finance sector is starting to be very aware of what are the relation between nature and the global economy. And this relation, if you see through the lens of the finance sector, it's focusing two issues: opportunities and risk. And a way to assess the risk is through the ecosystem service valuation and natural capital accounting. So this is another way to capture the value that it's not included in the current economy model. It's a way to capture the externalities that nowadays it's not included in our system. So this is a brief update or what we did during this project and a brief series of ideas or how this natural capital approach is used and could be used in the future. I hope that this presentation you find this presentation very inspiring, or at least it's what I try to do. If you have any questions, please feel free to do. I'm happy to answer any of you. Thank you so much.
Thank you, David. So, you have any question in the room? Yeah, one?
Please, easy question after eating.
It's an easy one. Okay, we have been talking for a while about the payment for ecosystem services, and we are beginning to see one of those. But how long it takes to have a market for biodiversity, for example, in your, when do you think that it can be a reality in Europe, for example?
Biodiversity market, it's a reality in Europe in different countries right now. There is a biodiversity market in Germany it was established 30 or 40 years ago. And as well in France through offsetting methodologies. There are different pilot habitat bankings in different places of France, in the south and in the north. In Marseille, La Couture, there is one. And in the United Kingdom, there is a program for habitat banking as well, was started 10 or 12 years ago. And since last year, now it's mandatory to make compensation of all the negative impacts on biodiversity through different sectors. This is in a mandatory point of view, but since last year and since the new global biodiversity framework and the new TNFD, the Task Force on Nature-Related Financial Disclosure Frameworks, are in the scene, things have been changing, and there is a lot of noise in the market, or in the market regarding how biodiversity credits could be implemented in the market. In a voluntary point of view, I mean, that means that companies are going to start or to set ambition in terms of biodiversity, as well as they have done for carbon. Let's explain a little bit of this. When I mean set ambition is as the same that companies set an ambition on carbon. I mean, I'm going to be net zero for 2030 or 2040. Some companies are starting to set their ambition for biodiversity in 2030 or 2040 or 2015. That means they are going to be they're setting goals for not to have any impact on biodiversity, or to have a net impact on biodiversity or positive impact. That means first that you need to measure what's your impact on biodiversity, and if you have, as a result of that, a global balance or negative balance of biodiversity, you need to offset or compensate your negative impacts. Based on that, companies are starting to make any restoration or regeneration projects, but they're willing to have different tools to make it easier. And the way to make it easier is through biodiversity credits. So there is a lot of noise in this, as I mentioned, and at the end of last year, through the Nature Finance Corporation, I guess, or different initiatives across the world, it's been launched, a new global initiative to set the rules about biodiversity credits and what's going to happen in the future, and how do you set your baselines, what in which terms you can use biodiversity credits or not, in a voluntary or mandatory terms. How do you measure, how do you quantify your positive outcomes, and so on. So there is a lot of work to be done in this arena. By answering your question, I don't know if in a short term a global biodiversity credit markets will be in place in 1, 2, or 3 years. I don't know, but considering that things are running so fast, and that there are very strong let's say, strong players in the market, which has been playing in the carbon market, and they are in the biodiversity market right now, probably this process will be accelerated.
Thank you very much.
You're welcome.
Thank you very much. Is there any other question on natural capital? So now you all know how to answer if you are asked what is natural capital. Yes. Okay. Thank you very much, David.
Thank you so much.
We follow the program. Now Fátima Cruz from the University of Valladolid. She will talk about social meaning of complex forest. ¿Tu presentación cuál es? Fátima Cruz, final.
So, hi everyone. We have been working about social meaning of forests, and so we switch off from just forest or economic value of forest to the social importance of forest landscapes. And also, it's a very different methods we use in this research, because we worked basically with qualitative methods. Talking about complexity, I understand, of course, when you say complex forest, you are talking about a structure of forests, but I want to call your attention for other kind of complexities or dimensions of complexity that are also playing an important role in the conservation, the development, and the use of forests. So it is inevitable related to social forest interactions, and that is what we have been working about. What we did. So first of all, we did a systematic literature review because we would like to know which kind of studies have been done in social issues in forest management or forest publications. Second, we did learning labs. It's a method or a methodology or perspective of research that put different stakeholders together, different stakeholders from different sectors together, and build a safe environment they put the perspectives on the table and contrast their perspectives, their point of views. And at the end, we are writing a guide for the inclusion of social meanings in forest management. So we try to help to take into account of this perspective. Techniques of research, mainly qualitative research. We did the systematic literature review. We used in-depth interviews and focus groups for triangulation and contrast of interpretations from different stakeholders or with different stakeholders. About systematic literature review, we search for studies in Web of Science and Scopus database. We found 3,481 first articles, scientific publications. We select 2,600 more or less that makes sense for us. Later, we select and analyze 220 articles and directly related with social meanings of forest. And at the end, we select 80 to analyze in depth. We built 2 databases, one with 220 articles and the last one with 80 articles. One thing is the increasing of interest in social issues in forestry. So you can see it really goes up in the last decade. We started in 2005 and finished in 2021. And you can see the impact of pandemia in the last year. So every publication goes down, and mainly in social issues, of course. You have the final report in our project. We analyzed the keywords that authors used to classify their publications, and we did a kind of semantic analysis and related the terms among them. David showed this image is the distribution of publications by European countries. Sweden is the higher, the top, and Spain is the second one. So the interest in this kind of studies in Spain is really high. We analyze which kind of methods authors used in their studies. And our question, or final question, is why include the analysis of social meanings in forestry? And for us, and I am a very rare social psychology in forest issues, so for me it's really interesting or important to know what people think and feel about forest and how we live into a forest landscape. Also to guarantee the efficiency and a good impact of forest policies is important to take into account what people think and feel about their landscapes. In the second product, we studied the social meaning of forest into 2 case studies, the same that David told in Palencia and in Comarca de la Vera in Extremadura. So we analyzed forest and place on social identity construction. So we did interviews, in-depth interviews and meetings with people, and we gather what they think, what they feel, what are their worries about the forest landscape surroundings. Also, we analyzed the opinions about traditional and new forest uses, what they do in the forests, and what they think about forest management. One important stakeholder in our research were forest technicians, forest managers, forest public responsibles also. Just as example, what people said, one important issue is how people feel nature, environment, landscape, mountains, or forests are fundamental elements in the construction of personal and social identities. It's not just trees. Trees and forests are part of their lives, and an important part of their lives. They really matter about forests. So some examples of qualitative data. So one woman said, I belong to this, I am this place, it means. And another issue is relational referent. I am this, but I am it with others. It's not only an individual perspective, but also a social reference. Some come from other places. One important issue is about depopulation in rural areas and the impact of the depopulation in forest management and the conservation of landscape. Social meanings of forest, we found different discourse, different perspectives, and we analyzed them in these five narratives. Forests are something alien, so it's not my cup of tea, it's not my point. Trees and forests are there, but I am here. So it's one perspective. Another perspective is forests as essential and basic to the local economy and identity, their identity. Also, we found people talking about forest as disappointment. So they expected a lot, mainly with the discourse of rural development. So they expected that to have some employment, some business related with forest, and at the end they couldn't do it, and they felt disappointed. Also, forest as a threat, so fire risks, perception, mainly when we are seeing every day in some seasons on news how fire forests are close to the villages are really could be a really dangerous situation. So they pointed it out. And also forest as potential development, like economic resource. Another thing we found is disagreements on forest management. We had several meetings with forest agents and forest owners and forest users, and we saw that there are two ways of seeing the forest. One from the forest responsibles and forest government in Castilla y León or Extremadura. They see the forest management as technical and efficient, and they are following the rules and the regulations and the laws, and it seems they feel satisfied in how things are working. On the other side, people, different stakeholders, women from women association, cultural associations, public representatives and enterprise representatives, they talk from a more critical perspective, and they talk about exclusion, vertical and punitive forest management. They don't feel part of forest management, and they don't feel taking part on decisions about their own territory. So, and they pointed for several conflicts about this. So at the end, we theorize about these meanings of forest in two different ways. One is forest we called living forest, people talking about traditional how, on self-management, shared cultural history. And another perspective, or not another main discourse, is managed forest, basically from responsible technical and forest engineers, and the technical know-how and normative regulation. There is not a problem about the existence of these two main discourses. The problem is when they compete from each other or with each other. Sometimes they compete and conflict came up. So that's the real problem. In our opinion, the challenge could be the mutual recognition and conciliation. How could we combine the two perspectives and help each other to be more efficient and to do better forest management? So at the end, our goal, we are just working, actually we have almost finished because just final review we are doing at this moment with a guide for the inclusion of social meanings in forest management. What the content of this guide is a summary of different stakeholders' perspective, what I have been talking to you about. A presentation of some tools and methods to analyze social factors' impact on forest management. So many times what we saw is forest managers don't know how to include these aspects in forest management. And so we can work a bit more in this way. And at the last, guidelines to integrate participatory methods and techniques in forest management. What people told about is the lack of communication or problems on the communication from forest management to the community, and explaining more and better how they do what they do, and how to engage the community in the protection and in the uses or in the techniques, more modern techniques or innovative techniques, or things like that. Thank you for your attention.
Thank you very much, Fatima, for this perspective, which is many times overlooked in forestry studies. So, do you have any question about the methods, the interpretation? No?
I think it's a foreigner language, perhaps.
Maybe you mentioned that you have made some interviews.
Yeah.
Some semi-structured interviews.
Semi-structured. We did.
Can you explain for us, which is semi-structured interview?
Okay. Yeah, of course. So we did 20 semi-structured interviews. We select 10 people in Palencia and 10 people in Extremadura, in La Vera. We interview them with some structure. There are different kinds of interviews. Some structured interview, you start with a guide. In my case, I use between 10 and 15 questions, and we introduce new questions during the dialogue. So that is the semi-structured interview. You have a first structure, and you include with what we call second questions to establish the dialogue. And we analyze the qualitative data. In this case, we did a triangulation, we call in qualitative research, contrasting our interpretation after the analysis of interviews data with the meetings and during the learning labs. And so people can say, oh yeah, we agree with that. Oh no, this you don't understand very well, or the people don't tell you the whole perspective, and we build the puzzle in this successive process of gathering data, analyzing, gathering data, and contrasting. This is the...
And just, do you think that is it possible to match qualitative data, qualitative analysis with quantitative analysis as we do?
Of course.
Because
yeah. It's very in fashion now, or very interesting now, the mixed methods called, and it's increasing the use of mixed methods at different level. You can mix methods at paradigm level, at technique level, or at the different points of view. So, and you can start with qualitative and cross later with quantitative, or the other side. So it's really interesting because with quantitative data, we usually get the panoramic point of view, and with qualitative data, you go in depth. So you try to explain why things happen, or why that result from quantitative can be explained from the people's point of view.
Okay, thank you. Any question? Just one question. Good.
When you say you select 10 people from each community, how did you select them? And how are you sure you're taking a representative
Yeah. Wow, we could stay here for several days talking about represent. In qualitative data, we never pursue generalization. So we don't try to be representative. We try to get significance, not representation. So our key informants are not representing more than themselves. What makes our research consistent is crossing different perspectives and showing the same object from different perspectives. And when we get this kind of cross, so I am teacher, so I would need some. When you cross the different perspectives and they legitimate each other about the discourse, so you get some transferable, not generalizable, but transferable knowledge. That's the idea.
Yeah, but how did you get the people? Like,
oh yeah,
you call them.
There is a technique that, called snowball. So you go and ask. For instance, we start in La Vera. We started by the rural development group. We think that is a main actor in the territory, and we ask them, who you think we must interview? And in the second round, we do the same and the same and the same. It's a technique called a snowball.
Okay,
so
thank you.
You go amplifying.
Thank you, Fatima.
And one thing, just I told you yesterday, the validity of this technique is based on the evidences. So when you read our report, you will see many fragments of, we call verbatim, fragments of the interviews. And everyone who read it will see that our interpretation is based on the reality and not is our imagination. So that is the validation of the technique or the method. Thank you.
Okay, thank you.
Thank you very much.
Está escondido. Los escondido ahí, sí, se ve. Okay, now we are going to the first presentation from our colleague in Canada. Now he is connected, okay? So,
hola Nacho. Hello.
Hola. Hola.
Hello.
Hello.
Oh, there is an echo.
Can you hear me well?
Try again.
How is it now? Some echo? Is it better now? Is it better now, Andrés? Is it better now? So I don't know if it's better or worse.
Important principle in computer science. Yeah.
Yes, sorry about that. We'll try to fix this as soon as possible. Nacho is professor in the University of British Columbia of Silviculture in Canada. And he has collaborated in some of the networks that has been presented here, like UMix4. Now, if you want that coffee, remember there is a coffee machine 3 floors below. So maybe you have time. ¿Así? This.
Sales donde están los ascensores, en las puertas laterales.
Ah, ok.
Las escaleras está la máquina.
Pero nada más entrar.
Sí,
La primera, no hay que bajar.
No, no hay que bajar.
Oh.
Sales al ascensor,
Okay.
entras por cualquiera de las 2 puertas laterales, subes unas escaleritas, o sea,
Sí.
hace como una U.
Okay, you are lucky. There is a coffee machine on this floor. Just go outside, and in the first door on the left, you can go there. Okay.
Okay.
Nacho.
Hello.
Di algo más largo, anda, que es que si no.
Hello. Can you hear me well? ¿Me oyes bien?
No, still we have the echo.
I don't know what's with the echo. Maybe it's the distance.
Ya lo he dicho antes, sí, pero no. ¿Eh? A ver. Say something longer, please. O sea, el perro de San Roque.
No, sorry. I'm just trying to touch here, adjust the settings.
I don't understand. We try to do it later.
Okay, let's try later, and I can do a test with someone else.
15 minutes later, maybe we can try again. Okay, thank you, Nacho.
Okay, so sorry about this. Maybe now it's time for the next presentation. It's Hervé Jactel from INRAE.
But then we have lost a lot of people.
No, not a lot. Okay. Okay. Still we can... What is your presentation here? It's...
Yeah, this one. Yeah. Hi, everybody. Can you hear me? Okay, so as Fatima said, forest is not only trees. There are some other organisms, like human, but also insects. And so we heard during the nice video of this morning that in complex mixed forests, there is a lower risk of damage by insects and so on. So here I will try to show why and how. But I will focus more on invasive insect pests, like exotic, non-native ones. Why that? This is because there are many and they are very dangerous. So they are not only many, but they're also growing in numbers. As you can see on the graph, there is a very steep increase in the number of exotic species, forest species getting established in all continents, following an exponential increase, like in the US, in Europe, in New Zealand. And you need to know that in Europe, for example, every year, 6 new insect species from abroad are getting established. So every year, 6 new pests that are non-native that can attack or damage our forests. So this is really, really impressive. This is mainly due to global change and mainly globalization in the international trade, with a steep increase in the number of containers that are transporting across the world, because containers is the main pathway for the introduction of non-native forest pests. For example, in France, we are very proud to have launched the biggest container ship. It's 400 meters long, and it can transport 23,000 containers each time. So you can imagine when you get this boat arriving in a port in Europe, you cannot check 23,000 containers on a day. So when you open the door, some insects that are associated with pallets, wooden crates, or potted trees and so on, they can escape and then reach the next forest and start making damage. So this is a very high threat to our forest. Not only because they can damage, but also because they cause a lot of economical losses. The natural capital is decreasing a lot due to this damage. And to get just an example, the emerald ash borer, this beautiful green guy, has cost already $25 billion in the US and in Canada. And basically, it started to eradicate all ash trees. I mean, the whole genus Fraxinus is got to be extinct due to this insect, because it can kill trees. And just to mention that this beetles is also right now in Ukraine. And for good reason, we don't know how quick he will invade the rest of Europe, but probably next year or in the following years, it will be in Poland, Germany, and so on, and he will continue to kill ash trees all over Europe. The oak processionary moth has been introduced in the UK, and every year 2 million pounds are spent to try to eradicate this pest in London, because it is very urticating, so they want also to protect the human people. So they are very expensive to manage. Not only they provoke a lot of losses, but also they are management costs, so they are very important issues. In Europe, we have a list of quarantine species. Quarantine species are those we consider the most damaging and dangerous. And you need to know that out of the 20 quarantine species of Europe, 15 are about woody plants. So the majority of quarantine species in Europe are damaging and threatening our forest. So we need solutions to manage these invaders, and of course there is no possibility to spray insecticide anymore on our forest, and in any case it was not effective. So we need to find something else to fight the threat and the exotic pests that are getting more and more abundant in our forest. So what could we do? We could try to know about the effect of tree species diversity on the resistance of forests against these pest insects. To know about the effect of tree species diversity, we developed a meta-analysis looking at papers addressing the question of whether a given tree species grown as pure or mixed stands would have more or less damage by a given insect. And so we calculate the ratio between the damage in the mixed by the damage in the pure stand. And if the damage in the pure stand was higher, the log ratio would give you a negative value. And so we managed to collect more than 600 cases where people have compared damage by a given insect on a given tree between a pure and a mixed stand. And the overall effect is a decrease in the risk of damage in mixed stands, less than 23% less damage in mixed stands than in pure stands. And quite interestingly, you can see that all types of insects follow the same pattern with a reduction of damage in mixed stands, being barb beetles, defoliators, seed feeders, and so on. But then we asked the question whether this applies not only to native insects, but also to exotic pests. So we looked at our meta-analysis, and we found only 2 cases of papers addressing the effect of tree species diversity on damage by exotic species, and they were from my lab. So, so we were not too advanced. So that was this paper where we compared the effect of the damage by the maritime pine scale, which is invading Corsica, and we found that mixtures of Pinus pinacer, maritime pine, and black pine, Corsican pine, was less damaged by this invading scale insect. And we also found that this, Asian chestnut gall wasp, you have it in Spain and you have it in Portugal as well. They are doing a lot of damage, and the yield of chestnut is highly reduced when you have a high level of infestation. And we found that we went to Italy, where this pest was introduced, and we found that a very steep decrease in the amount of damage as the tree species richness is increasing in the chestnut forest. But that was not enough to make a new meta-analysis, 2 cases. So we asked people, our colleagues, to try to give us our unpublished data, or even to start new assessment. And the protocol was very simple. They had just to look at triplets or pairs of pure and mixed species, at least 3 replicates, and they had to look at the damage by their own exotic species in their country. And so we managed to get 13 new species of non-native species, like the box tree moss, the ox legs buzz. You know this one? I don't know, you have it. It's a new threatening and worrying pest, which is defoliating all oak trees in Europe. All oak species in Europe are susceptible to this new invasive species originating from North America, and so we should take care of it. And this one is a defoliator of Douglas fir. Here you have the list. I won't go into the details, but you could see that there are quite a large diversity of type of insects, but also types of forest species. So based on that, we managed to get 45 cases of comparison of damage in pure mixed stands done by these non-native insects. They were all from temperate forests, so we used a subset of our initial meta-analysis to make a comparison between non-native and native insect response to tree diversity. And here you can see that we had still this reduction of 20% of damage in mixed stands for native, but for non-native it was also significant, and minus 32, meaning that our mixed species forests in Europe are more resistant to non-native insects than pure stands, which is quite interesting. And for all the types against of insects like borers, chewers, cone and seed, and so on. Here is Leptoglossus, for example, for the feeding on cones. So to summarize, because Andres told me to be very short, I would say that complex forests or mixed species forests are our allies to fight against non-native exotic pests arriving in Europe. The 6 new species every year that come to our shore and get established. As effective as we found for native ones. And just very quickly to explain how it works, there are 2 main mechanisms explaining that. The first one is that when an insect arrives in a mixed species, it has difficulties to find the host. For example, look at this conifer. If it's surrounded by Brody species, the Brody species hide the conifer to the insect because they are masking the silhouette or releasing repelling odors. And so it's more difficult to find the host when the host is mixed with non-host for the insect. And for non-native, it's more important because non-host, they have not co-evolved with the non-host. So the presence of non-host species is the main mechanisms why the host is difficult to find. And the second effect is a
top-down effect, because we found that in mixed species forests, there are more natural enemies, like predators, parasitoids, and so on. And we found that there are more generalist natural enemies, like birds or bats, which can feed or prey on any kind of new insects, and they are more effective at controlling non-native insects when they arrive in the forest. And that's it, and thank you for attention. I would like just to acknowledge all the colleagues that provided the data to make the new meta-analysis, and thank you.
Thank you, Hervé. I'm glad that you also see complex forests as our allies.
Yes, they are.
So do you have any question? Yes, one question here. David?
Thank you so much for your presentation, very clarifying. Based on your last slide, does it mean that the mixture of surrounding species across the forest is different if we move from one single species from a complex forest?
If I understand well, it's a question of scale, right? A special scale of the mixing?
It's not about scale, it's also about the number of species and the different adaptation of these species to the habitat.
Mm-hmm. What we found is that the contrast of traits between the species we associate is very important. The best result we got was a mixture of broadleaves and conifers. That's the first answer we can give to forest managers, and the proportion also is very important. We found that at least you need 25 to 30% of non-host species in the forest to get protection against insects. And then the third answer is that you can the closer, the more intimate the mixture, the best it is. That's for the bottom effect on trees protecting non-host trees protecting host trees. But for natural enemies, the effect can be spread across the landscape, for example, because you can imagine that bats and birds, they reproduce on broadleaf forests, and then they can move to conifers to prey on damaging insects of conifer trees.
So based on that, and considering that the insects may change, considering the mixture of species, that affects to the different number of bats and birds that you might find in the habitat, because they are not going to be able to feed in the same way?
Mm-hmm. Yeah, I mean, it's important because complex or mixed species forests, they have the ability to maintain high diversity and high abundance of birds, bats, and other predators. And this is why it's working. Because if you have a pure stand, you have a lower diversity and a lower abundance of predators or parasitoids. And as soon as a new pest arrive in the stand, they have it takes time to build up their population to be able to control the new prey. So it's important to maintain beforehand, preventively, a high diversity and a high abundance of natural enemies, like bats, birds, and so on. Miren, yes?
Yes, two more questions.
Three.
1, 2. You first.
My question was about, as you mentioned, with a more complex forest and a more diverse, you have a bigger diversity of birds, bats, and all that kind of predators.
Mm-hmm.
But my question is about doesn't this kind of complex forest or more diverse forest be host to more kind of different kind of pest provoked by insects?
Yeah, it's a good question, because as soon as biodiversity of insects increase, you also increase the number of species of herbivores able to feed on trees. But what is important is the ratio between the a quantity of prey and quantity of predators. And so we found that the ratio is positive, more positive in mixed forests than in pure ones.
Understood. Thank you so much.
I saw also.
Thank you very much. Another excellent presentation. But we can look at things with a kind of optimistic or pessimistic view. For what you mentioned, like the fraxinos problem and so on, and these mixed forests, do you think they are just delaying the process, or they kind of get? Is it possible to get a natural balance where things are getting into control? So is it the pessimistic view that in long term everything will die? Well, we know that we will die
at some point.
That's the end of all of us. But is it something that is completely unavoidable, or is it a trend to a more sophisticated process where these new components will be, let's say, controlled by others? What is your view?
So I will have a mixed answer, as in mixed forest. I am pessimistic for the number of non-native insects that will arrive in Europe, because nobody will stop it unless the economy will fall down. But I'm not sure about that. We will import more and more products from, and I forgot to say that there are more and more from Asia, which are tropical countries, and climate change help also the establishment of these species because they are coming from warmer areas. So I'm very pessimistic on that, but I'm more optimistic on the way our ecosystem can resist or be more resilient to that as soon as we improve the complexity or the diversity. And as you say, it's not only a question of reducing the damage, but also to delay the damage, because if we can delay the amount of damage, we can hope or expect that there will be an adaptation, genetic or ecological adaptation of our forest. So it's important to save time. Yeah.
Thank you.
The third question.
Thanks. I wanted only to know if what are the evidence or your impression regarding the last part of these slides in the part of the tree communication, tree defense. What could be the role in mixture, or this is not so important in business?
It's important. It's a very new area of research where we found that trees can communicate with each other. They are called talking trees. It's well known from giraffe in Africa, but for insects it's the same. As soon as a tree is damaged, the damaged leaves, they release some odors like methyl salicylate, which is an information, a stimuli understood by the neighbors to produce some chemicals to defend better against the next attack. So by combining a lot of trees, you can increase the possibilities that the communication works well.
It's not species dependent, this.
Sorry?
I mean, what is the role of the mixture in this case?
Yeah, it is about mixture because the odors that a non-host species is released act as a repellent. If you have, if you are in a pure stand, okay, let's say a pure stand of maritime pine, it is attacked, it releases terpenes, and terpenes will increase attraction to insects feeding on pines. Whereas if you have birch attacked by some aphids and so on, they will release some odors that are understood by conifer species, insect species, as a signal that the host is not there, they are non-host trees, so they will go away. I don't know if it's clear enough, but it's a we call it non-host volatiles, and non-host non-host volatiles are understood by insects as a signal that they are not in the right habitat, because there are no right host signals. We know that because, for example, barb beetles feeding on conifers, on the antennae, there are some cells to detect terpenes, so that they know that they are close to a pine species. But there are some other cells, sensilias, able to detect odors from broadleaves that tell them that they have to go further away to find the pines, because there are only broadleaves that are not good to develop on. So it's a question of behavior.
Okay, thank you very much, Andrea. So we're going again to try to connect with Ignacio.
Hello, Andres. Can you hear me well? Yep. All right, can you hear me well this time? Yeah. Okay. So thank you so much, Andres, for inviting me to be here. And oh, okay. I don't know. We tried before and it worked, so I'm not sure what's going on. I can keep talking, but I don't know if it's better or not. How is the sound at your end? Not good? I can hear you perfectly, yeah. Can you hear me well? Okay, is this better like this? Is it good? Yeah, let's go. Okay. All right, so I hope that you hear me well now. I'm sorry for all the technical issues. It's great to see so many familiar faces, and thanks again, Andres, for inviting me to be here and share a little bit about our experiences in Western Canada. So climate is changing quickly here as everywhere else. You can see some maps of Canada where you see the forested ecozones and it colored the managed forests, which are mostly south in the south of the border. And you can see that the expected rise in median temperature is going to be somewhere between 1.8 and 6 degrees, and there's also going to be an increased water stress, as showed by the map on the right, which shows the change in climate moisture index. And in general, there's going to be increased summer droughts, warmer winters, and longer growing seasons, and all that is going to have some implications in the growth and species composition, but also it's going to make the stands more vulnerable to disturbances. And the three main disturbances that we are they're expected to have a big impact in the next century in Western Canada are drought, pests such as insects and fungi, and wildfires. And I wanted to share with you this picture of a great wildfire that happened a couple of years ago here in the coastal area of British Columbia. And the main question now is if we're gonna, in these ecosystems that are not so adapted to fire, if we're gonna have enough regeneration coming after fire. You can see on the left-hand side a small Douglas fir trying to make it through. So the regeneration failure of some prevalent conifers, it's a major problem that we may face soon. Going back a little bit to silviculture and what we can do to restore sort of the complexity of the system. Here we also had a lot of old growth harvest, and there's been a lot of transition to what we call second growth stands. And by this we mean forests that have been planted. So there's been a lot of clear cuts, and after that planting. And this has greatly simplified the systems. And the idea now, as in many other regions, is to try to like increase that complexity, and not only to increase biodiversity and other ecosystem services, but also because it may like hold more buffer against climate change and disturbances. And if we think about what type of adaptive silviculture we can do in terms of a proactive management, we can focus mostly on the young stages. So from land preparation to density management or establishment. And of course, when we consider this at a larger scale, there are other considerations such as costs. But I'm going to focus today on mainly on the stand scale, and also in this establishment stage. And the reason also to focus on this first stages is that that's where we really have more data. This is on the left. You can see a figure showing the number of studies from sort of the mid-50s to until now, and you can observe that most of the studies that we have are from the mid-90s until now. So that's where we really have experimental data from, and from there forward, the stands are basically grown using models, but we don't really have data. And the only question that really I'm going to like try to give you some partial answers today is if mixed species stands can increase the resilience to climate change. And this is a nice picture of Douglas fir and hemlock here on the coast. So in this first example, we were interested in the capacity of mixtures to mitigate insect damage, following a little bit Hervé's presentation with examples from the other side of the Atlantic. So here we had some spruce lodgepole pine plantations in interior BC at a relatively high elevation, established in '94. And there were 3 densities and several species proportions tested. Here you can see a picture of a plot where there's like 25% of pine. You have the pine, the large pine on the right-hand side, and 75% of spruce. You can see the spruce on the left, just to give you a visual of how the plots look like. And what we observed was that the pines were growing in the mixtures as if they were growing at low density, meaning that they had the larger diameter when they were mixed with spruce, because the spruce was like on the understory. But at the same time, it seemed to create some problems with the wood quality. So there were larger branches than there would be like in the pure stands. But what we were really interested in was in looking at the positive effect that mixture could have on the damaging agent, in this case, spruce weevil. So spruce weevil, Ray can probably talk much better than me about this, but it's an insect that causes stem deformations, and basically it attacks the leader and it creates the lateral branches to compete for dominance. So there is some effect on height. You can see on the graph on the right that the tree is affected by weevil. The regression line is in red. Had lower height than the trees that had no damage. But the major sort of the major problem for forestry is that it decreases the wood properties through this. For example, you see there that crook stem. So one alternative or one idea is that perhaps shading, which will reduce the leader growth and then make it less attractive for the weevils, will be positive to reduce the impact of the weevil. So we tested that, and what we found was that there was less weevil in all of the mixtures, and you see there in black what the pure stands with only spruce, and the different sort of shades of gray and green represent the mixtures. And in some cases, even having only a 25% of pine was enough to reduce significantly the damage. So the second example, in this case, we're looking at mixtures as a way to mitigate fungi damage. Again, this is a relatively new experiment from 2004, where the focus initially was on wood quality. So the densities are very high, like 4,600 stems per hectare, and there's many different species combinations. So white pine, cedar, birch, Douglas fir, alder, many of the species that are here abundant on the coast. And again, there were different proportions, so 1, 2, and 2, 1 tried. And in this case, and it was interesting to just attend Hervé's presentation, because it's kind of a reverse problem. In this case, we had a white pine with blister rust, which was introduced for Europe. So in this case, a non-native species, which basically kind of decimated completely the populations of this species that you can see on the right, white pine, which was a very common species here in BC, but now it's practically disappeared. And one of the ideas, of course, is to have a genetic program with resistant varieties, but the other alternative is to see if, like, for example, through mixture, we can reduce the impact of the damage. And in this case, you can see that the blister rust, what it does when it's a minor attack, it just basically creates this a bit of a swollen trunk, but when the attack is like very severe, like on the picture on the right, then it will the canker will girdle the whole tree and kill it. And the idea behind the mixing is that self-pruning, having less branches, can reduce the spread of the infection. So what we observed, although these are some preliminary results, because we didn't look at all the combinations with other species, but it appears that when they're mixed, they are less damaged than in the pure white pine plots. You can see some more healthy in the graph on the right hand side, more healthy individuals and fewer dead individuals, although there was a very high amount of infection overall. So if we move like to a different damaging agent, in this case drought and heat events, we don't have so many data yet, but we do expect that there will be also a positive effect of mixture through spatial and temporal complementarity. And we're trying to look at it through different lenses. So one of it is like trying to couple tree growth data using point dendrometers and water use efficiency using sap flow measurements. And the other angle is looking at it from a three-dimensional change of shape due to drought stress. So we're trying to like understand a little bit the mechanics, but then if we want to upscale our results to larger areas, then remote sensing appears to be a better tool. And the last but not least, because it's a very important problem that we have here in Western Canada, as you can see, in between 2003 and 2017, the fires burned like more than 1.5 million hectares. So another question is if mixtures can mitigate fire damage, and this is quite difficult, as you can imagine, experimentally to see. In this particular case that I'm showing here, we had luck because the fire ran through one experiment. So I just put this sketch because I thought it was fired. It was funny to see the field notes that were like no fire, okay, some fire, gone. So well, we'll have to do something a little bit more scientifically. We want to get this published, but one of the mechanisms that we observed, and this is just purely a sketch that I made on the right, is that mixtures were creating the pine to lift its crown, and because of that, it appeared to burn less through low severity fires. So there are some mechanisms that positive impacts that mixtures can have also in preventing fire. And just a summary, well, mixed species seem to show significantly less damage, at least when it comes to pests and fungi. We need more data for drought, and fire will be a difficult one experimentally to get data on, as I showed. But in general, the conclusion, I think, should be also that operationally we do need more concrete information about stand densities, mixing proportions. So mixing can help, but we need this information. And also there may be like many trade-offs, as I was showing, for example, in terms of wood quality. So I think it's important to look at it from that perspective too, that there may be lots of benefits, but there will be some trade-offs. And just to wrap up and conclude a little bit on the way that I see that we can move forward this silviculture for complexity and for resilience is first to make use of new metrics that can give us a higher spatial and temporal resolution. For example, here I'm showing this images of a LiDAR with a drone. I think you were having some talks about it this morning. They can give us like a very powerful information about forest structure, but also about impacts of drought or pests directly. We need better integration from physiological mechanisms to wood properties, and we do have the tools to do it now. And last but not least, we also need to understand the role of this genetically improved species. So we're having, at least here in British Columbia, many programs for resistance to drought, for example, also to the rust and to the weevil that I showed. So how these are going to be like deployed in practice, and how are they going to like impact the size dynamics and damage dynamics will be something important in the future. And with that, I thank you for your attention, and I don't know if we have time for questions, Andres, but
Okay, so if you have any question for Ignacio, for Nacho? No? You say at the beginning that the risk of increase or longer droughts in BC, how long is the drought in BC?
It's actually quite dry, although many probably know that it is, well, here on the coast it is a rainforest, but there is a very marked like summer drought, and this it's happening in many other regions. It's getting longer, and we're also having like combined with the drought very strong heat effects. So this is causing, for example, a lot of problems with regeneration. This combination of drought stress and heat, intense heat in the summers. So no, it is becoming a a major problem here.
One question from Hervé.
Yeah, please.
Yeah, Ignacio. What's the current situation with the mountain pine beetle right now? And is the forest recovering?
Hi, Hervé. Yeah, thank you for the question. The big sort of last big epidemic was a few years ago. It has impacted greatly the whole timber supply. Now there doesn't seem to be, like, at the moment, such a big epidemic, but it's as you probably know, an endemic problem here, and I think that the good sort of the benefit from the mountain pine beetle was that it's been shown that a lot of homogeneity of the landscape was partially responsible for the outbreak being so large, and now I think that there's more thinking of moving in the direction of mixed species or other systems such as variable retention that are going to give more heterogeneity at the landscape level, and hopefully decrease the problem of pine beetle when it comes again. But it has had still wildfires and pine beetle have had a huge impact on timber supply here in the whole Pacific Northwest.
Thank you.
Thank you, Ignacio. Again, we are still behind time schedule. So
yeah, I know it's getting late.
Yeah. Thank you very much, and see you soon.
Thank you.
Bye. Okay, let's continue. We still have 2 presentations. I will ask you to be as fast as possible and as clear as needed. And also probably we won't have ya cierro. Sí, no, déjala ahí. Sí. Pero muévelo hacia abajo. I will ask you not to make questions. Sorry, but that no questions because we don't have time for that. So you're lucky, yeah. What is your presentation?
Cork nut something.
Cork nut. Okay.
Okay.
Okay, 15 slides.
Okay.
You can be on time.
Yeah. Andres was counting the slides.
Yeah.
He said I have 15 slides, but actually I have 6 slides that will run faster. Transition slides. So grab onto your chairs because we are going to run. So my name is Alexandra Correia. I come from Portugal. I am presently in the Portuguese India. I worked for 22 years in academy, in Institute Superior of Agronomy. And today I will show you the results of 2 years of the project Cork Nut, which started in 2021. This is a funded project by the National Portuguese Funding Agency. And this project is related with 2 emblematic species of the Iberian Peninsula, the Quercus-suber and the Pinus pinea that we already talked about today. So the name of the project is Mixed Quercus-suber and Pinus pinea Forests Management for Production, Valorization, Biodiversity and Forest Fires Prevention. The idea of this project is to actually get to the landowners and the managers to join these 2 functions, the production and the ecological part. So basically, what is the problem that we have now in Portugal? We have about 1/5 of our cork oak stands with dieback problems. This is also very common in Spain, but this is common to all the Quercinia in the world. But in Portugal, this is very frightening to the Portuguese cork oak landowners. Although we have 100 years of research, almost 100 years of research on these problems, we still do not have a solution for it. We know that climate change is involved, basically the increase in droughts. We know already that pests and diseases, either existing or new pests, are involved in the problem. Bad management options, for example, the use of machinery, heavy machinery damaging the soils, it's a problem. And landowners now are very frightened and unsure on how and where to invest, especially in which species that will provide them future income. With the cork oak, we have an additional problem, is that we have very low survival rates of installation, either natural or artificial regeneration in the field. It's very common to have like 20% of survival in the plantations. If we have drought years, we can have 0. Okay? So it's very frequent that the landowner has to invest the next year on new plantations 2 times, 3 times, okay? And this, they have to start to think well about this. But in any case, the cork, it's very interesting, because if we have the possibility of have good trees with good cork, we can have reach at 30 years old, we can have revenues of about 4,000 to 5,000 euros per hectare. This is very important. So what happens is the landowner wants to keep the trees, these cork oaks, but they also need a plan B. Because with the present scenario of climate change and global economic change, they need to have this plan B. And the plan B species is the stone pine. Okay? So what we see in the field, and this project started with my experience of 20 years of going to the field, talking to owners and forestry associations, is that landowners are starting to mix the cork oak with the stone pine, especially in the areas where they try to invest in arborization and they failed. So now we have this mixture of old trees with new plantations or natural regeneration of stone pine under the canopies of stone pine. Sometimes the landowner also promotes the installation of stone pine for grafting. And grafting is also quite appealing, because with 15 years old, the landowner can get an income of 2,000 euros per hectare. This is huge. So this mixture is presently very interesting for the landowners. So this project came to answer these questions. Can we mix these two species? Are they compatible? How can we mix the two? So we don't want this kind of mixture. This is a very close interaction. This is not what we want, but I find this picture very interesting, because the two species frequently come close. They regenerate right below the canopies. We are thinking of something more like this. Okay, the aim of the project, of this corknut project, is to investigate the dominant interactions between the two species. We are using growth, soil water uptake. We are doing some measurements of isotopic composition of water. We are using regeneration data. We are studying also the resilience to pests. We are focusing now on one of the most damaging, the Coroebus undatus, which is the cubrilla of the cork. I don't know the name.
Culebrilla. Cubrilla. And we are also looking at cone damages, both in pure and mixed stands. We are also studying the soil microbiome and nutrient status alterations in pure and mixed stands. And we want, in the end of this project, to provide guidelines for landowners regarding management options. Which tree density should they use? Harvestings, understory, when to do it, how to do it, grafting the stone pines, yes or no, in order to increase both cone production and cork, but maintaining or even incrementing the ecosystem services. So now we go to the results. Some results of our experiments in the greenhouse, and also some results of our field sites. So, did you wake up with this blackboard? Some results of the greenhouse experiments. So we started these greenhouse experiments in 2000 and I'm already showing the okay, we started these two experiments, the first one in 2017. This was part of my post-doctoral graduation. And we've run this first experiment during 11 months. And what we did was this time we did not have the project, so I did not have money to go to the field. So I had to work with what we had in the laboratory facilities. So we started with this experiment running during 11 months, where we make this combination, these 5 treatments, where we have the stone pine growing alone, the cork oak and the stone pine growing alone, and then we had the monoculture mixtures, cork with cork, cork oak with cork oak, and the mixtures of stone pine with stone pine, and then the two in the same pots, okay? And then we decided to run a second experiment. This time we are trying to see the effects of inoculations with Phytophthora cinnamomi to see if the cork oak was more resilient to this pathogen, if in presence if combined with stone pine. The problem was that this second experiment lasted for 18 months because we were waiting for the cork oak to die, but they didn't die. They didn't die, they didn't show any signs of damages, absolutely nothing. What we found is that we were providing water, light, nutrients, and the plants were able to recover very well. So this second experiment, which the purpose was to track Phytophthora, we didn't use it for this purpose, but we found very interesting things with this experiment, which I will show you next. So the first experiment, we harvested, basically destroyed the plants at 11 months in the end of the experiment. And we were very interested to see what was, how was the strategy of root growth and competition between the two species. We find out that the two species have very different ways of exploring the soil profile. So the quercus, as you can see here, the priority of this plant is to grow a pivot root that this is made at the expenses of the acorn, okay? So it produces this lignified taproot that is, the priority is to reach the groundwater levels, in this case was the base of the pot, and immediately when it gets to the to the bottom of, or when it reached the water, it started to produce the secondary root system. In the case of stone pine, it's completely different. We see here that he immediately started to produce the fine roots, the lateral roots, very dense. It almost occupied all the layers, the strata of the pot, while cork oak only uses this lower part of the pot. We also find out, because we were harvesting the plants every 3 months, that the stone pines start to produce mycorrhiza, to form mycorrhiza also very early in age. With 3 months, it was already full of mycorrhiza. So we find out that under optimal growth conditions, the two species exploit different soil niches in the pot. And we find out that there was a clear facilitation of stone pine over cork oak because of this early mycorrhization that probably led to a different microbiome in the soil that led to improvement of the leaf area index and also the soil nutrient status of the cork oak. Okay? This was for the first experiment, 11 months, 1 growing season. So we go to the second experiment, 2 growing seasons. And now I ask you if you have any idea of what happened in this case. So the pots with, as you can see, the pots with the only one stone pine, they perform the best. They grow much more than the others. And as you can see here, there was a clear mono-specific competition. Both, when they grow together, both stone pine grow less than when alone or when the stone pine is mixed with the cork oak. But what do you think it happens with the cork oak? It was completely in competition, in strong competition with the, when combined with the stone pine. We see that they grow much less than the other two, okay? And we also observe that the mono-specific combination, one of them will also deplect it, okay? So, very interesting. What happened was that facilitation prevailed until environmental limitations were present. When we limit the space of the pot and we observe that the growth of stone pine area, leaf area, was shading the stone pine, we saw that there was a strong competition of the two. So one of them have to go out. As this, can we relate this to the field? Can we use this data to the field? Well, we don't know. But my perception is that this is, in fact, occurs in the field. What we frequently see is that cork oak easily regenerate below the canopies of the stone pine. What happens is that if the canopy is very dense, the cork oaks benefit from the shading because they like the shading in the first stages of development. But if the stand is very dense, in some point in time they have to come out to allow for the cork oak to grow. Okay. Field sites. We also have another component of the project, which is related with the collection of data in some plots. We have a set of triplets that we also discussed here today. Miden has 86 triplets. I only have 6, but we are in halfway of the project. So the triplets are a bit hard to define in the field and to look for them in the field, because this involves a conversation with the landowner. We have to visit the site. We have to have a big area with the three mixtures, the pure and the mixture. We have to have a big area where we can mark the center of the plot with at least 30 meters radio and a 3 meters of buffer area. So this is not easy to do in the field. But now we have more or less scheduled that we will do at least 12 in this project. And we also have a set of plots that I call the plantations. And these plantations are very interesting because these are plots that we inventory in the field and represent voluntary initiatives of the landowners that decided to make mixed plantations. So this is very interesting because owners have different perceptions of what kind of mixtures and how the density should be and where to invest their money. And this is interesting. We also have 7 examples of this plantation, which we will follow for the next years. So some results, for example, for the Coroebus undatus data. We have now 6 triplets. We have 350 trees monitored for the Coroebus undatus. I will not go in details with this methodology of collecting the data, but basically we use a ruler, and then we count the number of galleries in the cork. In the cork, no, in the stem. Cork needs to be removed at least they have to be removed at least 2 years back. And then we count the number of galleries in 4 sessions, and in each of the cardinal directions, yes. So what we find is, this is preliminary results, is that we saw a lower attack index of Coroebus undatus in the mixed forest, okay? This is not statistically significant, this is a trend. We observed a very high variability between the trees, but we also found, and this one is statistically significant, is that the number of null cases, that is the trees completely with no galleries, are much higher in the mixtures than in the pure stems. We also found that the cones are less attacked when mixed. These are the damages, visible damage in the outer bark of the cones. These are damages caused by Diorictria, Pisodes, and this one is Diplodia. And we didn't open the cones, so we don't know the damages inside, so we cannot say nothing about the Leptoglossus. But here again, we have a less incident of attack in the mixtures compared with the pure stands. And we also found, since we have 3 years of data, that the damages are higher in non-masting years, as we can see here, okay? Here. So in conclusion, facilitation seems to predominate while resources are not limiting, then competition prevails. Proximity silviculture, opening the canopies and removing trees from the system as the stand develops, this is one recommendation. We saw lower incidence of Coroebus undactus in mixed stands compared with pure stands, but there is a high variability, so we need to collect more data. We have lower incidence of damages in cones in mixed stands also. So preliminary results, mixing the two species seems a viable management alternative for landowners. So I thank you all. I invite you to look at our webpage. I want to thank the team members, all the students that help us, master students, doctoral students, and also the landowners that are really a help for us. Thank you.
Thank you very much, Shana. Any question? No? Question. Okay, perfect. So, the last, not the least, presentation is by José Luis Tomé. ¿Dónde está?
Está el nombre al principio.
Tomé. Okay, thank you very much. Good practices to integrate fire risk in complex forests. Thank you. Vale, 16.
Thank you very much, Andrés. We are very tired, so I'm going to try to be brief. Take into account my English is not so good, so if you need to question anything because you don't understand, please do it. Okay. Now I'm going to present this product. This is the product of good practices to integrate fire risk management in complex forests. And we have been working in this product with our companion of ISA, with Leonia, Katarina, and the Professor Rego. Of course, we have two pilot study areas. One, we have seen it this morning in Álvaro Serra de Omarao Natural Park in the north of Portugal, and the other is in the Sierra Cebollera Natural Park in La Rioja. It's the same zone that Jorge has shown this morning to us, okay? These are the activities that we have done to prepare this product, but I'm not going to talk about this here because we have a little explanation here later. The first thing that we have done is try to see how this kind of information is part of the forest planning instruments in both countries. In both countries, we have analyzed 6 different plans. In Spain, we work with like the planning of the natural space and also with some forest management plan of some forests in the area and also in a plan of all La Rioja. So they are not very specific in forest fire. What we have found when we checked 14 items related to complex forests and fire management is that most of the plans don't integrate information about this kind of stuff. And as you can see, we don't approve, and in the average of the score of the 14 items that we have evaluated, but especially taking into account the integrated forest management for forest for fire risks, the plans have still a lot to improve if we can't take into account this stuff in the management. Okay, the situation in Portugal is a little bit different, I guess, because some of the plans are related to fires, so these plans are better. They take into account more of these 14 items that we have studied, but the conclusion of our colleagues is that not in a practical way, so still there are some margin of improvement in this kind of plans. The most important thing of the product is this methodology, where we try to define a system in order to identify strategic management zones.
these strategic management zones are zones where it's especially important the fire risk management in terms of trying to stop big fires, and also in terms to give to the firefighter an opportunity to attack the fire in a safety way, okay? So we have 3 steps. One is the forest fire simulator, where we work with some input data, and we are looking for some output data, such as minimum ultraviolet tile, burn probability, and high-intensity flame length, that we are going to use in order to get some result about the axis and node of propagation of the fires and the wildfire risks. And at the end, what we want to do is design these preventive actions, and for that, we are going to try to identify the best places in order to do this, and also which is the best prioritization for optimize the investment in this kind of stuff. And another thing important of the methodology is that we find that it's important that at the end, a field work done by any person who has an expert knowledge about firefighting improve a lot this kind of stuff, because at the end we have a double target. One is that we reduce we reduce the combustible. I don't get the fuel. Thank you very much. But the other important thing about this strategic management zone is that they must there must be an opportunity to the firefighting in order to attach the fire in a safety way, okay? So taking into account their knowledge in the field is very important to get the best option of this kind of stuff. Okay, talking about input data, one important thing is that nowadays we can have a very precise cartography, such as this cartography of forest field map that we use in La Rioja, based on remote sensing, and especially using LiDAR information. So better cartographies mean a better simulation, and now we are more prepared than in the past to have this kind of information in an easy way. Here you can see 2 of the output data that we have used in the methodology. Here we have the flame length and the linear intensity. All the colors that are orange and red are out of the capacity of a firefighter in order to attach the fire. So the probability of so any fire in these areas is very difficult to extinguish. Here you have similar output data in Alvaro Serra de Marao Natural Park, the forest field map, and the flame length that they calculate in the same area. And this is an interesting slide because it explains a little bit how the methodology works. We use the propagation nodes that here there is a map where the density of these propagation nodes and the propagation axis that you can see, it's working? Yeah, here, to identify the best places to localize these areas. On the other hand, we use the probability of burning, okay, and the high intensity in order to prioritize where we localize it and do a better investment. And at the end, we use the knowledge of the people who go to the field work in order to do it in a proper way to the fire extinction. And here there is some result for our companions. They did 9 simulations, dynamic simulation. Some of the fires come from the west and the other from the east. And for each simulation, they have a map like this where they have all the nodes and all the axes of the fire, okay? After identifying which are the best places to locate these strategic management zones, we try to analyze the effectiveness of these preventive proposals. Okay, so what we have done is simulate that we did these preventive treatments, and we changed the fuel models, okay, in these areas, and after that we ran again the simulations. And when we did do so, we can see how the fire risk changed from before the treatments to after. In this case, it's easy to see how the color of the map changed, and now here, after the treatment, we have much more green and yellow. That means that the fire risk decreased, okay? We have analyzed 4 items in terms of reduction of the prevention for management, in terms of the average of the values of linear fire intensity. For all the forests of the Sierra Cebollera Natural Park, we get a reduction of around 40%, and if we are talking only about the surface of complex forest, the reduction is about 60%, okay? If we are talking about the percentage of burn canopy, the situation is a little less impressive, but we are with 35% in all the forests, okay? And when we talk only about complex forests, we are around 38%. The burnout probability is reduced about 38% for all the forests and around 35% for complex forests, and the fire risk is reduced about 58% in all the forests and 71% in all the forests. And in this graphic, you can see only for the complex forests of the area how they reduce their fire risks after the preventive proposals, okay? This is the situation for the Álvaro Serra de Marao Natural Park. The results are consistent with ours, especially in the more complex forests that they are here. This is, I guess, this is the classification you show us this morning, Leone, and this one, sorry, is the Altraplan area with ules, with some pines and eucalyptus, and the other 2 are pure stand or stand dominated by Pinus pinaster and other pines, okay? So, to conclude, as I told you, the strategic management zone understand and those places that maximize the effectiveness in preventive management to stop the forest spread and give opportunities to the firefighter to work safely are important. It looks like they are efficiently and effectively tools in order to reduce the rates of fire. We propose that it's necessary to be proactive with this kind of management in order to reduce the fire risk. And we think that the identification of these areas but also the treatment and, very important, the management in the future of these areas must be incorporated at all the territorial planning instruments that we have done in the past and that we are going to do in the future in order to fight in a safe way against forest fires. And that's all for my part. Thank you very much.
Thank you very much, José Luis. You have questions, we can do it later. No, thank you. Yeah, sorry about that. Actually, we only have 10 minutes for the round table, the conclusions. So I'm going to be... Yes, hello? I'm going to be quick. For the round table, I invite here to come Xiomara, Pilar, and Fatima. Here's one. I just want to point to two aspects that has been raised in this during this symposium, this meeting. Si queréis, si puede ser sin ella, mejor, porque hablar un poco de las cosas que yo voy a decir aquí y ya está. Improvisamos.
¿La pongo? Sí. Después, cuando termines con esto.
Sí, claro. So, here we like just to, the name of this symposium was to be in the strong sustainability of complex forests, social, ecological, and economic interdependence of ecosystem services. And I would like just to stress this strong sustainability concept. Maybe you are more familiar with the intersection of these three pillars. You have this intersection of the environment, the society, and the economy. Under this perspective of a strong sustainability, it's more a hierarchical point of view. So in the base is the environment, then the society, and finally the economy or the economic growth, which basically means that we cannot have economic growth without the social acceptability and outside the limits of the environment. So this is the main idea of this strong sustainability concept. So in my opinion, it's something that we can discuss briefly here during this short round table, is if complex forests might be considered within this concept. And also, under this concept, we can also discuss this slide that I'm very proud of. You know, this idea that if complex forests are always accepted or more accepted than other kind of forest types like plantations or not, something that we can discuss later. But here we have three representatives of three aspects that we have worked a lot in the group. Oh, maybe this is not the, sorry, this is not the right one. No, but it's okay. It's all the same. Yeah, so what we have learned is not, actually it's not the focus group, I mean it's the stakeholder engagement. So the need for a stakeholder engagement, Pilar is going to tell us something about how she tried to engage stakeholders, if it has been easy or difficult or impossible sometimes. The social participation, and I like this managed forest and living forest concept that Fatima has mentioned. So probably we can discuss, probably we are more focused on management and managed forests always in our proposals or scientific work. We compare managed forests versus unmanaged, and sometimes we just overlook this living forest, the people living in the forest and from the forest. And communication, we have also learned how important it is to communicate research projects from the very beginning, to include the communication part, not only at the end of the project with the results, so I have the results and then we present all the results, but from the very beginning. And Xiomara can tell us what her experience. And put here also this productivity, because we focus a lot of ecosystem services and multiple ecosystem services, but still timber and biomass, it's very important. And productivity of timber and biomass is still an asset also in complex forests, it must be. To be honest, I find that most of the presentations here about complex forests
have been about mixed forests, not irregular forests, just from one species with a different age structure or size structure. Probably this is because the background of the partners in the project. But we have to bear in mind that also irregular forests might be considered complex. And probably it could be also very interesting to analyze if these irregular forests are more resistant to pests than mixed or regular forest. So I would like just to give the floor just to Pilar, that is going to present first you can just talk about the stakeholder engagements, your experience, and of course, now this is a round table. We are open to questions, to comment, and anytime.
So yeah, I'm gonna be very short. We had a lot of problems to engage in stakeholders in the discussions. We tried everything. The only thing we didn't try was to call one by one on the phone. But I think maybe the problem is that how we approach them instead of going to, we are with this project, help us with that. We need to implicate them in a different way. And we called for a workshop, no one registered. We made phone calls, no one registered. We made another workshop, and then we had 30 people come in. Then it snowed in Valladolid, very few snow, and we had very few people there. So it was like, we tried to analyze it was not interesting for them, but then the people who came really were very interested. And for the participative workshop, not many people stayed, and we made them draw what is a complex forest for them. So like they were again in school, and at the beginning they were like drawing, really. Okay, yes, it's in a video, so you can really feel it like, okay, drawing, and I'm not so sure. But after 15 minutes, they were like, okay, I have to put this here. And we have to design some zips here. And they were very engaged in participating and building that idea of complex forest for them, and then adding information about what were the problems, what were the opportunities, what were possible solutions. So we got a lot of information in just 1 hour. So it was great, but we had very few people. And we have been trying to organize this again online, and everything is prepared, but we haven't engaged them yet. So we proposed one date, and we had 5 people. And we had to postpone it because with 5 people, you cannot get many information, or at least not enough information. It's not worth it. And we told them we're gonna postpone it. And everybody wrote back like, yeah, please tell me when you're organizing this, because I'm really interested in that. So I think we need to insist and present this idea of what we want to get from their participation, how we want to engage them. And I will send it just tomorrow or Monday to Andres for everybody to see what we have prepared in Miro. That is an online tool that you can make very nice things and participate approaches online, because it's difficult when you have people in place and people online together. That's super complex. But when everybody's online, you can make them do very interesting things. But really, it's been very hard. And I think this year has been very full of meetings and workshops and getting the people to get information, because it was the year after when we could everybody meet. So we could meet everybody. So that was very hard. But we're happy with the results of that workshop.
Thank you, Pilar. Now, Fatima, can you tell us your experience about social participation? And of course, again, if you have any question, we can also include this.
Yeah. So following Pilar ideas, now I started working in rural development project in 1994, And I am really, yeah. No, it's another one. No, it's another presentation. I am really a believer on social participation. Yeah, social engagement. Thank you very much. So I think the main issue is trust. When you call people to come to participate in some activity, they have to trust that that activity will be interesting for them, not only for us. People on the territories are very sensitive, or even, I am so tired, but are very desconfiado.
I think that sometimes they feel people from outside wants to take their...
Yeah,
they don't
people.
trust.
Yeah, people feel used by researchers, and they don't trust that what we do really is important for them, not only for us. And I think participatory research methods is a key issue. So.
And they need to receive feedback after. When you get the information and you work with them, we need to go and present them the results, because if not, they feel like it was not worth it.
And participation is a long process. It's not one-day activity. So we have to link one activity with another and create a real process. So that's the idea of learning lab, the learning laboratory. So learning together, that's what we propose since the beginning of COMFOR-SUDOE project. And we tried really hard to do it. And it's important to call people and to tell people what they will get from our research, not what we need from them. I think this is an important issue. And if you do it several times, they will trust on you. If not, they will reject or just pass. So that is, and Learning Lab is, has a theoretical ground, and it's important because we usually think and work in the top part of the iceberg on events. But at the bottom, there are mind models and ways of thinking that really motivate our behavior. So when we work with participatory research methods, we are working in the whole levels, in the 4 levels. So this is one of our meetings in Palencia, and the previous picture was in La Vera, and even Andres and I saw some pictures of the event we did yesterday to tell them our results. We get them back what we learn from them, or we learn with them, and that is really important. It's an adaptation of, I don't know if you know, the Arnstein ladder of citizen participation. Usually we stay, and even in, you know, the Yeah. The forest management plan theory say that you have to the population and has to participate theoretically, but usually we just keep them in the first or even second level of participatory ladder. So we ask them about things, but we don't engage them on the decision levels, and we mainly, even we don't listen what they say. We just do the things to take a picture or to get their signature and don't listen what they say. And they know. So it's important. Trust is the most important thing for participation. And trust is a long-term process. I think that is the main idea. So we all want to be at the top of participation. We all want to be part of the results, the process, the decision, what we do in our territory is important. So that is the idea of participatory research methods.
Thank you. I would like to, it's a very strong thing what you say, that people feel that they are used by researchers. I don't know, we are researchers, a lot of researchers here. I don't know if you have that impression too, that you are using people's land, people's forests, because we have a question that we might think that is very interesting, but maybe it's not the question that those people have in mind about the forest. And I would like to know if after this learning lab, you feel that some of these, participants can change their mental perception or mental, you say the word, the mental models about the specific problem.
As I said, I think it's a long-term process. So in the previous European project, a Seamwood project, you participate on it also. We create an association on Palencia model forest. So we create a structure to keep working together on our territory. And so I think it's possible, but our commitment is as important as there. So it's not easy. And we are in so many tasks and so many activities, and sometimes we are not able to pay enough attention about other needs.
Maybe one way to solve this engagement problem with the stakeholders and with the society, it's a good communication of the project from the very beginning. So I don't know, Xiomara, from your perspective, how do you feel?
I had something to, if you can look for it there. But before, what you were talking about, I don't think it's something that people from the field feel bad about researchers. I think it's something about rural people and urban people, and it's something that is going on, it's been going on through decades. I think it is, because all the urban people has developed a lot, and the rural not. And it's not that they have not developed, it's that the feeling is that they are less developed. They know less. And I think that's something that is really deep in the mind of many people who live in rural places.
Yeah, just one. I think that is a stereotype about rural people, because rural people are so diverse. I am rural one, and I was born in Rio de Janeiro, but I live in a place, in a village, with 40 neighbors.
Yeah.
So.
I'm not saying it's that. I'm saying that the perception.
Yeah, but there is a lot of.
That one here in Spain. That's what I feel.
Yeah, but I think it's a lot of prejudice, mutual prejudice, and there are so diverse profiles of people in rural areas, scientists, farmers, entrepreneurs, so that's so diverse. And for instance, 28% of women living in villages below 500 inhabitants are graduating at the university. So it's a lot of people. They studied and they are so diverse.
Yeah, I totally agree that it's a prejudice that we have. But I'm here to talk about the communication stuff. Well, I'm Xiomara Cantera, and I work at here at the National Museum of Natural Science as, doing press stuff, a press officer. And for me, I want to share with you that it's been a real pleasure to work in this project, because I'm really interested in the topics of the COMFOR-SUDOE project, personally and professionally, and because, well, I want to highlight that we've been in the project from the beginning, and that's what has made a great difference with other projects, because I've been working with scientists many years, and I usually find out about projects like this when they are at the end, because somebody that works, that has been, I don't know, 2 years, 4 years in a project, they suddenly realize that they have to communicate just because they ask them to communicate in the project, and they don't have anything, so they come to you, oh, we have, what can we do? And it's like, maybe it's a little late. In this case, Andres called us, I don't know, when I think when you didn't present, you hadn't presented the project when we talked the first time. So we were aware of the project from the beginning, and that, as I already told you, that makes a world of a difference. I broke everything. Okay. Okay. We had these two strategies. I'm gonna explain it like really fast. We have this scientific dissemination and scientific communication. The main difference is communication. We are talking to journalists, people who work in media. And in dissemination, scientific dissemination, we are acting with people, directly with people. As an example, an exhibition will be dissemination, because you create it for everybody, for people who goes to a museum. But a press release or a meeting with press, that's communication, okay? In this case, the communication part was done by the European Institute of the Cultivate Forest, the IEFC, from France. They were responsible for the communication part, and here at the museum, we work with the dissemination project. well, we've been working together anyway, but those were the roles. The first thing we did was to create a logo and a corporate image, and I'm so proud of you because most of you have used the templates, so that's a good news. And we create a website which is in Spanish, in Portuguese, and French, and in English. And we had it, I don't know, 6 months at the beginning of the project, or 3 or 4, I don't know, but pretty fast. Then we send a couple of press releases. We will probably send more because after the project, we will have more scientific articles, and we will probably write another press releases talking about the project, even though it will be finished. The media coverage was pretty good, and we're happy with it, and also I think it's going to go farther. Oh, okay. We also have developed many campaigns in social media. They make 4 videos in 4 languages, and the coordination, the strategy with social media was based in using hashtags because then you can find what you've been doing, and implicate partners, because we are a lot of people, and in social media, if we are many people talking about the same thing, it's a good thing. I mean, we'll get farther. Besides that, they have done some seminars and some scientific and technical publications. And then we go to the dissemination strategies. I'm going to go a little fast because we are all tired. We made Andres and Elena, who's not here, but participate in many fairs, dissemination fairs, as like Madrid es Ciencia. In that one, the educators from the museum went to tell the project, well, not tell the project, to show the workshop we've developed to teach and to show the project. And they've been in the European Research Night in 2021 and 2022. In both fairs, I think we calculate we have like around 4,500 people watching or viewing the project. We also have written a couple of articles in the magazine Naturalmente, which is a digital magazine. We published every 3 months here at the museum, and it has more than 1,300 subscribers. I've done it again. But the thing we are more proud of, it's the workshop the educators from the museum have developed for students between ages from 6 till 16 years old. This workshop shows the students the relevance of the mixed and the complex forest. And the good thing is that we've used it in the urban camp. We have it here every summer. We use it in 2021 and 2022, reaching more than 600 kids. We have shown that same workshop in a couple of teachers group to show them how they could teach these things. We use it with schools, we use it with families. We have done Ask the Expert, with an activity for families where Andres and Elena were telling them directly what they were doing, all the things they've been doing. And well, the best thing is that since we knew about the project from the beginning, we could integrate it in our daily work during these 2 years. And actually, these educative activities have become part of our regular dynamics at the museum. So we have this data for these 2 years, but we're going to use the same thing for many years after the project is done. We also have done a marvelous exhibition that I guess you've seen during lunch. And we did the disseminate video about complex forest that you've already seen because we put it this morning. This work that we do, it's well, for any scientific project, it's important that society knows about it. But for something like this, that needs the compromise of people, it's totally imprescindible. Yeah, totally necessary. And well, in this case, it's been so good being part of a researchers team that for me, this is going to be an example I'm going to use many times to show how things have to be done with communication and science. And I don't know if I said everything, but I'm here if you have any questions. And I want to say, I'm here telling this, but I'm only the one who's telling what we've been doing. Everything has been possible because we have a great team with educators, with the researchers, and well, I wanted to thank them, all the people from exhibitions and everybody, because without them, we couldn't have done anything. And thank you very much.
Thank you, thank you. And yes, that's really amazing. This is the first time that I collaborate with a press officer, so and very professional. And also, I must add that also ECOAXA collaborated in this dissemination with this part and the dissemination plan. I would like to know if you mentioned that thousands of kids and people have have contacted a bit the project. Do you have any feedback from them? Is there any mechanisms to see if the project or our communication and dissemination efforts have been successful?
The feedback we have is the feedback at the moment.
Okay.
Because you're working with kids. We have the feedback of the teachers who really evaluates the whole course we do and the part about mixed forest and complex forest. But most of the things we do are for people, for kids, and the educators know when something is working right, because you see it. That's a seed that you plant, and you will know if it survives, just like you do with your plantations.
Yeah.
You will know if they survive 20 years ahead.
Yeah. Yes.
But the feeling with, and the educators team has a lot of experience because they've been working in this field for more than 30 years. The feeling is really good. The feedback they get in fairs and with the kids is really good.
Thank you. Pilar, you want to add something?
Yeah, I had just one little presentation, but I cannot access to the Google Drive.
Okay.
But it was with the images to show what happened in the workshop. I told you that in the beginning you see a drawing of all the elements of the forest, that it looks like it's made by children, but it's not. And then you see all the elements that were added there. all the information, all the positive and negative things added, and all the possible solutions that came up just in 1 hour. So I think it's difficult to put the people to work in a participatory way, because sometimes they're not used to do that. But once you get them to do that, you get a lot of information. Like really in a very easy way, and it was just 1 hour, and really it was something very easy for them, and it was not a boring meeting like someone talking like for 5 minutes, and then so everybody could add their information, and we really got like a lot of information from that. So if we can continue that work, I think we will make and combine this after with preparing in a better way that this draw, we could have like something very nice about what's a complex forest. Because in fact, when we put the people to draw what is a complex forest, they draw a landscape. It was not just a forest. So that was very interesting. So we are talking about forests, so really we're talking about landscapes, and landscapes mean people. So we need to work with people.
Yeah, I strongly recommend you to have a look at the report of that meeting and that exercise. It will be uploaded in the documentation of the project, because it's what's really interesting to have that exercise. So, do you have any question to experience? Yes, Asier?
Thank you very much, and congratulations. Only I have a question. Do you think people or stakeholders know the importance or the opportunity of this kind of forest in the future? Could be this a problem to find more people to participate or no?
I think people who live next or close to a forest do know the importance of the forest. But I think there's a great disconnection between people who live next to the forest and people who live in the cities. But, well, I don't think it's something about just forest. I think it's something about nature in general.
The question is this kind of forest, complex forest.
I don't think so. I don't think they know. If you're talking about complex forest, no, I don't. I still think there's a gap that we have to fill, and we have to communicate, and we have to. But I think when you tell people about it, it's really fast. So it's not like you're talking about the importance of, I don't know, a little bird that lives in, that it's harder for people to get involved. I think with forest, I don't have data, but I think with forest is different.
Yeah, I think people and we are avoiding meetings in general because we have so many meetings. And they need to see a meeting as very useful. Sometimes it's easier, and we did it in Palencia. It's easier to invite people for a walk into the forest, and it's easier to engage people in other kind of activities more than formal meetings, because they associate a meeting with someone talking about a strange thing. And we need to change this idea, but using participatory methods, active techniques to increase the level of participation, real participation.
Martelloscopes could be a good option for that.
Yeah, I was going to talk about that telescope. I've been going with Fatima with education students like several times, and you explain them a lot of things about forest management, and they have fun. They don't want to cut any tree, so all of them. So it's like, and it's very funny how, and very interesting how they see the forest in a different way. And for these participative approaches, I have one example that I made something similar like the thing that I prepared for this, for the forest, the Spanish strategy for forest genetic resources conservation. And we had 70 people working on the same time, like in different rooms in Zoom and in one Miro board, each of them in their parts, and working for 2 months together. But we had like short meetings of 1 hour and a half. Then they have 2 weeks to work on they wanted to say, and then we were working in phases, like making this strategy. And at the end, it's something that we couldn't have done in being present, because for them it's impossible to be like once every 2 weeks go away, and we made it like they were changing of groups, and it was something very dynamic, and of course using post-it and writing sort things, and we got a lot of information, and with information of 3 meetings, but 70 people working on the same time, we had the strategy almost done. So it's because it was something that they were very interested in, they were part of the project, and then at the end you have a strategy that is accepted by everyone. So it's really, that's an example of the success, and it works. It's like how you implicate them in the process is very important too, for them to be part of that.
Trust and implication, but also there are some strategies, because when we organize some event or some activity, we must know who will be a good leader to attract people. For instance, when I prepare a meeting, I know who I must call and ask them to help us to attract people, because that people trust on them and not on me, because they don't know who I am. So it's a kind of the technique of snowball. It's also like that. So when we prepared this, some of these meetings, we had a colleague working in this COMFOR project, and he called several people, and no one paid attention on him because they didn't know him. I said, okay, I will call. And I made some calls and asked other people, made another call, and we get the people because they know. So it's a kind of trust chain. And we have to know that. If not, we will be frustrated because they are not interested. But it's not true. We have to know how it works and to make it work.
Yes, it was just two minor things, but I think words matter, and when you try to attract people, you attract with the concept of complex forests. And I don't know if complex forest is a very attractive expression to, so we is it, how difficult would be, or diverse forests, mixed forests, possibly it's more attractive than, you can attract easily than talk about complex. the idea of complex people. We are all complex, but there are some issues about complex. And the other thing is also the setting, as you were suggesting, the way to communicate. Well, we heard today that plants communicate with each other. Plants communicate with volatiles, with insects, and so on. So the communication the media is extremely important. And even the word symposium literally is to drink together in Greek. So that's something that we'll be doing possibly in the next phase. And I think that this is probably one of the best ways for people to communicate, is to have these more informal settings that the Greeks already knew with the symposium idea. And I think we'll probably take advantage of the symposium that we'll have after this session also. Yeah. But thank you. It was very good to have your presentation. Thank you.
Thank you very much. And I think we must to translate to communicate, we need to translate our message in different language to different public. And that is, yeah.
You have to translate to the people you have to translate your message thinking of the people who you want to get to. If you're doing a workshop for kids of 6 years old, you're going to use one language and one way to explain them what is a mixed forest or a complex forest. If you're talking to a 16-year-old group, the same. And in communication, it's translating, is telling things the same way you will tell them to a friend that doesn't work with you and doesn't know anything about whatever is your specialty.
Another thing, we had a meeting yesterday in Extremadura. Andres was there, Cristobal and I, and it was really interesting see how people pay attention when you say some word or name some place that are familiar for them. And, oh, that's close to my house. That I walked there when I was a kid. So when you really know and translate in meaningful things for them, that is a key issue also.
Yes, you have any more questions? I think that with this information, probably we can have a true symposium later during the dinner and make some conclusions, and tomorrow during the General Assembly we can approve the conclusions and maybe we can make these conclusions public. Thank you very much, all of you. Only 39 minutes ahead of the time schedule. So after the farewell from this symposium, which is being recorded, I will give you some practical information about tomorrow, about later today. But most of all, I would like to give you a big thank you for coming and stay here, for your presentations, for your participation in this symposium and in this project. Thank you very much.